I've been doing sales all the time, myself and Kenny, we've been doing that. I know some of you we've been communicating on email, but we haven't met each other. So today we have the opportunity to meet each other. So this training is this is the second training that Victron we're able to conduct in Fiji. I think the first one was in 2017 or 18. Yeah? So we are very fortunate to have a master trainer here. Also, just for the training, so it's going to be today and tomorrow. I hope it's going to be very compact, and you'll find a lot of interesting information. Also, if you have any questions, please don't hesitate to ask. If you don't want to ask, maybe you can write on a piece of paper and just put it, have it in. Yeah? For lunch and refreshment, it's going to be at 12:30 to 1. So we're giving you 30 minutes window. The reason is we might finish maybe earlier than 4 o'clock as planned. Yeah? So the faster you come, then we can start with the, continue with the training. Also, just for housekeeping rules, first thing is phone silence. If you need to answer your phone, just put it on vibration and maybe you can just go and check. Yeah? Be on time. We're supposed to start at, well, I said 9 o'clock, but you know, 50 times. So. But you all did very well today because you all came with, before 9. So that's quite good. We have a photo session that we want to do with Ashna. So this is before we go for lunch. So we want to make sure that everybody comes in. And the washroom, you can use Crazy Bike's washroom downstairs. Yeah? And, so this is what's going to happen. Well, you all know Ciaram now, but if you want to know more, you can go to his website. That's all the work that he has done. Yeah? So just yeah. And before I hand over to Tony and Ciaram for the main session, I just want to say, in terms of my role, it's mostly to do with pricing. So for all the trade guys, we will give you our trade price, which is quite good price. Yeah? I mean, we all have to make money. So we help you guys, yeah? Everybody's happy. If your customer is happy, we're happy. Yeah? So with that, I think I will give it. Oh, Tony, say this, please. You want to say some more?
Well, let's just wait till this boils up.
Yeah.
And everyone get a coffee because it will probably hold the floor for a few hours before there's a break. So, and there's a few more expecting to come in. Is everyone here using Victron products at the moment? Or some people here haven't used it yet and looking to start learning how to use it? Yeah, everyone's using it?
Cool, do you want me to start?
Well, unless you want to go through your company and who you are.
Yeah,
and then
I'll
have a
start
break
that and then have a
coffee
quick little
and
break, yeah.
And then get into training.
So, thank you very much for having me here today. My name's Ciaram Granger. I'm from Adelaide in South Australia. We have been a Victron distributor in Australia for nearly longer than 10 years, possibly 12 years now. We've been building power systems with Victron from really small stuff all the way up to the really, really big stuff at the capacity of what Victron can do. And we have done that, successfully. We've learned a lot along the way, and that's hopefully what I'm here to kind of teach you guys today or run you through the experiences that we've had with Victron, and give you a bit of an overview of the product, what it's capable of, what you can do with it, and then, you know, basically, if you've all been building with Victron previously, we can then sort of start looking at questions and answers and things that you've come across. So, like my background is I'm an electrician by trade. I've been an electrician for 20. Should know these dates, but yeah, about 20 odd years now. Let's just leave it at that. And so I started back in my apprenticeship doing solar, and I was a contract installer. Used to install solar panels on the roof in the really early days in Australia that were grid connected. From that and learning that as my trade, and we did a lot of the commercial, electrical and other bits and pieces as well, but the bit that I absolutely fell in love with was doing solar. And back when I first started doing solar systems in Australia now, solar systems have gotten quite large even for residential houses, but back then we used to install 5 and 6 panel jobs, and you know, it's up to now, you know, we do commercial projects that, you know, with a couple of thousand panels. It's amazing where it's gotten to and the technology's gotten to. So in about 2012 or 13, we became a Victron distributor. We fell into it by accident. We had no wholesale experience, none of that. We were just a trade company that was using Victron products. Using Victron products, we had a really high level of capability with figuring out how Victron works. And luckily for us, when the distributor in our state decided to drop the products, we swooped in and got offered to be the Victron distributor. With becoming that is a very, very steep learning curve, because Victron runs from everything from, you know, caravans and RVs to marine to, you know, residential houses to commercial projects. There's a lot of product to learn. And one of the things with Victron is that your support network is your wholesaler. So there is no calling Victron on the telephone to ask for support. The way the network runs is you have to come back through your wholesaler. So there's really big importance in why you need to choose the right wholesaler to buy from, because those guys are going to be the ones that give you the help when you need it. So yeah, becoming a Victron distributor was a very, very quick learning curve. You learn a lot from dealing with issues and system issues and problems, and hopefully we can run through some of those things, and maybe tomorrow, if we've got a few breakout sessions, if any of the techs want to talk fault finding on systems and any of those bits and pieces, we can kind of do that. But today I'll probably try and keep it pretty general. So in doing so, we started from doing very small Victron systems. We started single phase 5 kVA, which is it's a small system in Australia, and we are now up to we did the largest Victron system in the Southern Hemisphere, which is Southern Ocean Lodge, which is, there is one that is bigger than it, but it's 2 separate systems on one site, but it's a system we won an award for this year, which was the National Clean Energy Project of the Year, which was Southern Ocean Lodge in Kangaroo Island. We also previously won it for another project we did for William Creek. They're both 3-phase parallel systems, quite a lot of solar, quite a lot of battery, and a lot of custom control stuff in there, which Victron is now very capable of doing a lot of custom control. And so that's kind of a bit about us and our background. So my business in Australia, we have not overly big, but we've got 25 employees. I'm the director. I spend a little less time in the field than I once did now, managing people. But it's always great when I get to go out and commission projects and jobs, and I'm really thankful to the Solar Fiji guys for having me over today to come here, and I've got to go to a couple of jobs and get them all up and running and working, and it's been really good. So it's the perk of the job really. And you know, we've done projects on all around Australia, and we've been here, Vanuatu, and hopefully we can do more and help you guys with Victron in the future. So we the couple of key I asked my marketing girl to put this slide presentation together today for us, so I had something to present, and I thought I'd just run through a couple of the key projects that I've done in the last couple of years, and these are the 2 award-winning projects that we've done. One is William Creek, which is a whole town in the middle of Australia in the desert. William Creek's a big tourist attraction. We have a big lake in the middle of Australia called Lake Eyre, and William Creek is a hotel, pub, camping accommodation, and in its peak season it gets a lot of tourists into the town, and they originally ran this site completely from diesel. They had a 110 kVA diesel generator, and they were spending up to what would it be? It's nearly about $500 to $600 Australian a day just in running their diesel generator. So I'd been dealing with this project to get this project across the line, just in the terms of time frame with off-grid power systems. This one took 8 years to get across the line and convince the customer that burning diesel was not the way to go. I actually, the first time we ever looked at this project was with a company that Tony would know is Energy Matters in Australia, and it just never went anywhere, and he kept looking and looking and looking. But eventually technology, where we're at the moment, is in a very, very stable place, and being so stable now, and the benefits of having things like lithium batteries and bits and pieces, now was the opportunity for him to put a system in. So this is William Creek. Up the top here we have a 200 kilowatt solar array. Panels that we use were Trina for this project. We use a lot of Trina with my business. We've had a really long relationship with. We've got 9 Quattro 15s, 8 450 200s, and 5 Fronius Simo 20s. I think they're all Simo 20s from memory. And we have a 280 kilowatt hour battery bank using Pylon Tech. Now Pylon Tech I've used for an extremely long time. I've probably installed over a gigawatt. This now we've got the projector working. What I might do is I'll just run through for these basic systems or smaller systems that people have been installing, and just pretty much the easiest way of going about programming Victron product. As I mentioned, when you're programming with a computer, if there's no Bluetooth available on the device like the Multi Plus or the Quattros, you'll need this little tool called the MK3 dongle. It's a there's 2 versions of it. You can get it with the USB VAT-A thing, and it comes with USB-C as well. They're a really important tool to have in your toolkit. So when we're programming systems, there's and this is the bit that gets everyone extremely confused with Victron, because there's multiple ways to kind of go about doing it. When we've got really basic and simple systems, Victron have been slowly working their way through to using this app called Victron Connect. It's taken them a hell of a lot longer than what originally was planned to to integrate it and make it work to the functionality that it works now. But it also it makes it really quick and easy to do things like firmware updates. It's easy to do the basic level of programming for systems, and you can program just about every Victron device using this app. The shortfall of using Victron Connect, if you're doing a system that's AC coupled and got a Fronius inverter or a SMA inverter attached to it, you won't be able to set this up from this app. You can't do programmable relays, and you can't program assistants or any of the assistants by using this app. When we bring up the Victron Connect app, just another quick thing to point out is we have these two tabs here, which is local, which is devices that if you've got your phone, you've got Victron Connect up and you've got charge controllers, the smart solar or anything that says Orion the smart solar range of stuff, smart battery protects. In local, it pumps out its own Bluetooth signal, and you'll see the device. You can click on it, you can enter into it, and make all your setting adjustments. If you're signed into your VRM account and you've got multiple sites there, any VE Direct device or CAN bus device, you can actually dial into the Victron Connect version of that device. So you can dial all the way into a charge controller, you can dial all the way into anything remotely as well via Victron Connect. So it's a feature that some people don't quite know. So when we go up and bring up it, and I'll run through a couple of the systems, and I'll start with a Victron inverter. You can bring up demo products. So demo products, if you're looking at just playing around, getting familiar with the product, finding out what settings that you can set. This is the demo library is the opportunity that you have to just play around with it, adjust things, see what each of the settings do, and it also gives you descriptions on what each of those settings are. In a live example, what we would do is if you were connected to a live inverter, this is what it would be displaying for you. It would be showing you what the battery state of charge is, what the AC input is and connected to, and what that limit has been set to, and then whether the output is switched on or off at the moment. That's just the basic overview of how that system and what charge state that we're currently in. Also gives you just the very, very basic data that's available: battery voltage, output voltage, input voltage. When we're programming, so when you hit the little cog up in the top screen, there's a couple of things that you can go in and check. I always recommend for every system that goes in new is to do a firmware update. Firmware update the charge controller, firmware update the inverter, get it all to the latest. Victron Connect is really good at making that happen, because as long as the app's been updating, it'll automatically should detect that it's old firmware and want to go through the update process. If it doesn't automatically do it, you can always check it. Once you've hit settings, the little three dots pop up here, and you can go to product info. It doesn't show us because it's a demo, this one, but generally it would show you the firmware version. It would say, and if there's a possible update, it'll have a little update tab. You hit the button, it goes through the motions. When we're in the settings, there's a whole bunch of tabs that we basically run ourselves through. And so this is for the basic setup of an inverter charger. In all systems, a lot of these, a lot of the time, probably most of these settings stay really as a default. The thing that we would change commonly is the input current limit. So depending on how big the generator that is that you're attaching to it, or how big your grid connection is, you would set that input current limit accordingly to whatever that needs to be. And It's a really important thing. We get lots of customers that don't set it or they forget to set it, and they'll connect their generator and their generator will trip straight away, and they'll be like, well, I don't understand why it's tripping. And it's most of the time it's probably just because they haven't set the limit of what it will be. If the Victron's told it can pull 50 amps, it'll try and pull 50 amps. That's it, or it'll bring itself up to that over a period of time. We have some other settings that are kind of associated with that. This one, I won't worry about external current sensor because it's only multi plus 2 related, but there's a feature here called dynamic current limit. What dynamic current limit's designed to do is it's designed to be softer on your generator. Some sites, from experience, it can work extremely well if it's sized correctly and set correctly. Some sites, it doesn't work at all, and particular generators don't like it. What it means is that what it does is it throws battery power at the generator to try and slow it, having to ramp up very fast to cover up big loads. So in sites that have really, really small generators, it can sometimes be helpful, but it's just worth, sometimes it's just trial and error. You can turn it on, test if the generator works, watch how the generator feels and sounds, and all of those things are really, really important with that input side, is making sure you're hearing it, listening to it and watching it and making sure that it's operating in a smooth, with smooth behaviour. The other important thing to have here is we've got enable battery monitor. So one of the cool things about a Victron system, some of you, if you've been doing really small systems, probably some of you have been dealing with the BMV battery monitors and those series. If everything in the system is Victron, you don't need a battery monitor. If you've got a GX device, the GX device can take all the data from everything and give you what the state of charge is. And where you would set that originally would be in this battery monitor tab. So generally when we would turn that on, you would set your capacity. You've got your state of charge when bulk finished and your charge efficiency. So it's a few of these settings that are in here. Battery capacity, when you bulk finish, a lot of these will change depending on what type of battery is selected or the charging algorithm further on down the track. But it's always important. I always tell our guys, when you're setting these things up, is just enter the data, enter the amp hours, do the bits. Just fill out everything that you can, because the system, the more data you have in the system, the better that it is. We then jump across into the grid tab, which is quite blurry and kind of hard to see. There's a few settings in here that, again, are quite important to how a system's going to operate. There's a functionality in Victron, and if you've been dealing with Victron for a long time or even just a little bit, and you've had to connect a generator to it, there's a function in there called UPS, and that UPS setting makes sure that the system transfers at the pace of what a UPS should transfer at. It's really quick, and it doesn't have, it is quite sensitive as well. And so quite often what we find is with generators, the transfer doesn't need to be at that UPS rate, unless you've got very, very ultra sensitive equipment attached to it. But most computers, most of the other bits, they're not too worried about that being so fast. So with that setting on, what we quite often find is a generator, when it's got the UPS on and the generator is connected to the system, the generator, when you connect and dump a load onto it and do all the bits and pieces, frequency can wobble, voltage can wobble, and the UPS function goes, oh, that's not good, and lets go of the system. And then it'll go back into that cycle again and try and connect it, and it'll drop out. If you're ever having trouble with Victron connecting to a generator, the first step is, we tell everyone, is to disable the UPS function. And what it then allows to do is it allows the the range of which that wobble and the frequency can wobble, it allows that to be much wider, and then it will allow your generator to connect. The generator will correct itself, and happy days. You also have your high voltage for your AC and that high voltage and low voltage connects and reconnects. The defaults are pretty stable. They're all really good unless you start using parallel systems. What we quite often find is 180 volts is too low for a cutoff in most scenarios with parallel systems. It's a lot of current that you're forcing. If the site browns out, which I imagine you probably have a few brownout scenarios here in Fiji with poor power from EFL, that if it gets to that point and the inverter decides to switch and the voltage is extremely low, if you've got parallel inverters, it can be a cause to blowing relays and bits and pieces in the system because it's pushing the current right up at that point, trying to suck power through to supply the load. And then you've got your grid codes and standards there. Is anyone here doing grid connected ESS systems with Victron? Or not really? Mostly off grid. So in that scenario, it doesn't really matter a hell of a lot. When we're running through the next part of like setting up all the inverter settings, a lot of these defaults are kind of left depending on like what the type of battery is that you're using, whether it's managed or a lead acid battery or it gets really job dependent. But it's always really good to find out from your manufacturer what the low shutoff is for your battery to protect it in case generators don't start. All of those bits and pieces. You want to disengage as much gear as possible. If the generator fails to start and you've got an AGM or gel battery and the system stays live and keeps sucking power out of it, you'll destroy your battery bank in a really, really short amount of time. And so finding out from the battery manufacturer, most of them will have a specification that'll tell you what their low point is. In lithium batteries, if they're unmanaged, they'll have a low point that'll be their warranted point. They don't want it to go below that. So setting it is quite crucial. You can also set it by state of charge as well. If you've got a shutdown, it's required based on state of charge. We quite often set this setting here, which is the state of charge shutdown on all of our systems. We do a lot of managed battery systems that have their own safeguards in place, but what we've found from experience is if the battery is the reason that the system shuts down, the inverter won't restart itself because it thinks something's wrong. So we quite often set a state of charge shutdown on nearly all of our systems that we install now. Again, any of these sort of settings here have got little descriptions of what it actually means and the bits and pieces. So when we get into the charger tab, again, you can set the max charge current depending on the size battery that you have. Really important to work out so you're not overcharging the system or overcharging your battery or charging it too hard and too fast. Your absorption and float voltages are all pretty self-explanatory. We have the repeated absorption time, and this is just to do with Victron's battery adaptive charging algorithm. And so depending on what type of battery it is that you're using, a lot of this data on most of the new batteries and lithium batteries, you can find what it is that they want to be set to. And then looking through battery specification sheets is really important to find that out. And then setting your temperature compensation as well, as we were talking about before, is another really key bit to finding out what that temperature compensation needs to be. If you have a system and everything's plugged in together, having everything plugged in together, lots of this data can be fed between all of the devices. and it'll talk and it'll communicate and make sure that all of that stuff is actually happening and doing what you've set in the system. Finding out from a lead acid battery manufacturer temperature compensation is super key to getting that life out of the system, because it'll affect what voltage it kind of tries to push the battery to, based on if it's cold, if it's hot. So it's keeping everything healthy. You also can set charge curves and all the bits and pieces. We have two different types of charge curve. You have an adaptive one, which is Victron's algorithm for lead acid and gel batteries, and we have fixed. Fixed is used for lithium batteries because generally the customer will give you, or the battery manufacturer will give you particular specifications for how they want that battery to be charged. The absorption time, all of those bits and pieces will be very regimented in what it wants to do. And most lithium batteries don't have an absorption time, so that the last roll off of what happens in a battery, that just doesn't exist. So when you're using lithium, you tend to have it set to fixed. There's a few bits in here. If you select lithium batteries, it automatically flicks it back to fixed. And probably the only other one setting in when we're looking at basic setup of a Victron system is, depending on how good your grid is or how good your generator is, there's a setting here called WKC input, and everyone always asks why is it in the charger tab, and what it does is when Victron goes to synchronize with the generator, you have the sine wave of the inverter and you have the sine wave of the generator, and it tries to make them line up and be exactly the same before it closes the contact and brings it in. WKC input allows the sine waves to be slightly out from each other, and it allows the charger in the system to operate on a completely different sine wave than the system. And what that kind of means is it doesn't need to be precise for it to connect. And in doing that though, it becomes a little less efficient, but it also means under all circumstances basically that the system will connect to that generator, it'll stay connected to it, and it'll run. Some sites that we've dealt with in the past, WKC input is you have to have it on. Larger sites, it's quite preferable to have it on, and you kind of build around the issues that it could potentially cause. So yeah, it makes your system a little less efficient when a generator connects, but it's kind of really key in some systems just to make sure that it connects and stays connected. Good. Outside of that, these first lot of tabs up until charger are basically the main basic settings that you need to set in your inverter charger to make sure you've got an operating system. We can do things, there's a few other bits that we have with the AC input control that you can set, which is the virtual switches, what they call it in other Victron products. In doing some of these bits is like in really simple systems, if you have a grid connection but it's terrible and never works, you might want to ignore it all of the time and let the system and that operate. But if the grid is required or the battery runs flat and you just want to bring the grid in to charge it all back up, or a generator, you can set some of these conditions up. I won't go too far into the AC input control, but you know, we've done lots of sites. So we just finished a site for a radio tower in Adelaide that had an AC feed to where the tower was that was extremely small for what the load is, and we had to put a battery system in place. It could just do the load, but if you put the voltage maybe, let's as an example, 240 volts. As soon as we put like a 5 or 6 amp load on it, the voltage would drop to 220. And as soon as we had, the guy originally put some solar panels on to offset the cost. As soon as he put the solar panels on, when it pushed power in, it skyrocketed the voltage up to 260 volts. So it was a really terrible grid connection. So we've gone in, put a battery system in place, and what we do is we ignore the AC input on that. The system completely operates off grid, but if it really, really needs to, it'll connect to the grid. Hopefully it only ever really happens outside of sun hours and in the night time, and operates that way. So it's a really effective way of just bringing it in and out as required. The last bit that we kind of have, which is probably useful for guys that are doing marine, you can set now in Victron systems, it's prioritise wind and solar. So like wind and a lot of sources, so if you've got a boat as an example and you're connected to shore power, but you don't want to use shore power to charge batteries and do all the bits and pieces, you can select other energy source, like prioritise other energy source, and what that would do is it'll only charge the batteries from solar or wind generation or external sources that you've got, and if the battery goes flat while there's a grid source there, it'll just pass through for the time being. So it's a useful feature if they're getting charged in a dock for kilowatt hours that they're using. It's just a neat little setting that Victron. It's only been introduced in the last 6 months, something like that.
So you mean to say it does, the charging curve does affect if it's not incorporated in the solar?
Yeah, so if you've got a grid, so if you connect a system like an off-grid system and you just connect the power source to AC input and there's no programming in it whatsoever, it'll automatically just charge. Like as soon as you've got an AC input source, it'll come to its input limit and use that power to charge, supply the load, do whatever it is. What they found in lots of boat systems is in boats mostly because of Victron in the Netherlands, is they would have these customers that put these big systems in, they'd go and dock, plug their system in, and their solar would do nothing, their wind would do nothing because the battery's full, and it doesn't work. They were getting charged kilowatt hours and stuff for having the boat docked. What this does is it just makes sure that it only uses the bare minimum of grid that it needs to. So if you run your system flat, it would just start passing power through and supply the load, and then when your solar kicks back in, it would charge up and go that way. Yeah. So it's a useful little feature in that scenario. We get lots of like caravanners and RV and automotive guys that are using it, and it's worked really well. The other way that you used to be able to do it was using ESS, but they prefer it not to be used for mobile applications. And it's mostly to do with grid synchronization with grid codes. Yeah. So that's kind of a run through of Victron Connect just on an inverter charger. You can bring up, like in all of the systems, there's help and manuals. So if you click on it, there's a paper here on like a generator FAQ. So you can, like if you've got questions about any generator, like, you know, people have come, like if you've got a problem, you're probably not the only person who's ever had a problem with whatever it's doing, or whatever the site's doing. Someone's always probably dealt with it at some point. So one of the things to do would be have a look at the FAQs, Google it, search it. If you don't kind of understand how portions of things work, Victron have most of that data available, and those PDFs available for you to actually run through. So this one has the Victron Connect V bus, and it'll give you all the steps, all the meanings of all of the settings, so you can kind of get an understanding of it. And then here we've got the multi-plus generator FAQ and the adaptive charging. In just the other products that are here, if you've done a Victron solar charger before, same thing again. They're a pretty stable product with Victron, and you would have probably used one of the Victron Connect apps to set one of these up. There's a bit more data that pulls into the system that is really quite handy. You can see what it's been doing each day, in what cycles it was doing what, how much power it produced. And you can actually graph, it will graph trends and bits and pieces that are happening with your battery. There's a couple of bits in before when I was showing you that you could dial into these remotely. One of the things that I use when I'm remotely trying to look at a system or figure out what went wrong, the VRM data, so the data that comes from the GX device and puts it to the portal, that data is an interval data, and it quite often doesn't give you the, depending on the product, doesn't give you what the voltage, max voltage or the low voltage was. If we have a low voltage fault, it might be whatever the low voltage was over that interval, and it might not be as low as what it actually really got to. Whereas the charge controller actually registers that minimum voltage, and it can be quite handy to see if you've got cell collapse or battery collapse. You can actually see what the low point was of the battery. When we're setting one of these things up, it's exactly the same thing. So you've got that max charge current here. You can, with that max charge current, set it to whatever your battery bank is, whatever you need it to be at based on the manufacturer's specs. Always set it to that. If you always have the charger enabled, but then they have the rotary switch as well on the bottom of the charge controller. That charge controller, depending on if you're using Victron batteries, there are some defaults, and you can just set the dial, and you don't even have to really dial into it. It knows what it needs to be. You might need to set the charge current, but it'll put all the correct charging algorithms in. If you're not using Victron batteries, which probably is like, from our side of things, we don't use a lot of their batteries, so we're always putting the system into what we would call expert mode and setting all of our own algorithms. So we would change it from the rotary switch to user defined. Then that opens up all of the voltages that you need to set. So your absorption, float, equalization, your revolt voltage offset, which just means it falling back into bulk based on how low the battery got. The absorption type, whether it's adaptive or fixed. It's kind of, there's a lot of settings to get your head into around here. So the other thing we were talking about before was equalization charges on batteries and using it to extend life. Equalization quite often is a very similar voltage to what the absorption is going to be. Some batteries will set an absorption, they might set an equalization, they might be slightly different, but a lot of the batteries that we used in the day, like Narada and a few others, used to just give you the equalization voltage, which is what we used for absorption. In systems that were really under the pump or hit really hard, we'd have to set a longer equalization time. So once a month, we would push that battery into equalization, and so do that absorption at a fixed time over 8 hours or 6 hours or whatever the battery manufacturer had specified. I've seen batteries that specify some crazy equalizations, from everything from, like, we had one battery that we had done some work with that they wanted 15 hours of equalisation time every 11 days. And that was like on a really big site. It's a huge amount of time. It's a lot of generator runtime to be able to pull that off. So, yeah, there's a whole bunch of settings in here from your just configuring your battery setup, just to make sure that you're getting the maximum amount of life out of your battery. At the end of the day, everything's about extending battery life. That's the most expensive part for your customer. They need to make sure that they're getting their bang for buck out of it. You'll also see in there as well, right down the bottom, we've got the temperature compensation. If you have particular products like the battery sense and the smart sense, make sure you're setting that temperature compensation, because as we mentioned, the Victron, as we kind of mentioned, the Victron defaults may not be necessarily suited to Fiji, or the battery settings might not be necessary. It's a European, like a standard setting. So,
So all the parameters are detailed in the battery spec.
In the battery spec, yeah.
Except for environmental conditions.
Yeah, except but they should have environmental conditions in the battery spec.
Right.
So, but quite often you just have to double check with your manufacturer. Are these settings that we've got from this manual suitable for where we are in Fiji and humidity and all of those bits? Otherwise they'll probably have it in the manual of what you need to set that temperature compensation to. But really important, it's really important just to ask and talk. Like if you don't ask the question and destroy a set of batteries, and especially if they're in warranty, dealing with the battery manufacturer on overcharging or not charging correctly, they can tell with a battery that it's been abused or not set up correctly. They won't give you warranty, and the customer will come back to you and go, well, I'm not paying for it. It's a really, really crucial thing. You've got to protect the battery at all costs is what we kind of like to say. Yeah, it's a really important thing to be making sure you're covering yourself off. We were talking before outside about batteries and just installation in general, and I've seen it here with photos of jobs especially on smaller sites where guys are chucking batteries in on concrete floors. Don't do it. Have them on rubber, foam, a pallet, anything but concrete. It's another thing that is really quick at destroying your battery. Astrification separates the acid, eats the plates. It can be really bad for the life of the actual battery system. So anything you can put under it to keep it off the concrete floor, just anything is better than doing it. We use like foam mats in Australia for doing it, but I've done sites where we've left them on pallets. It could be quite endless with what you do. Pieces of timber, uni-strut, metal, tubing, just whatever you can to get that, stop that temperature differential. Yep.
What do you recommend in regards to this? Is it recommended to pipe connect?
It depends on. So for those who didn't hear, that was like with the battery cable coming from the system down to the battery, of like what to like whether to put it in conduit or leave it out. It really gets down to, if we went off Australian wiring standards, cable needs to be mechanically protected, whether that be in the plastic conduit or those other bits. Double insulated flex cable falls into a bit of a grey area, where you can have a lot more of it exposed, but you want to make sure the cable is double insulated. I see a lot of cable, well, I haven't seen a heap of jobs here, but some of the jobs I have seen here, a lot of it's just been single insulated cable. You'd want to be putting it in conduit for customer protection, I would say. Quite often we put a lot of things in duct, cable tray, keep it all neat so it looks a bit nicer than flexible conduit. But yeah, it's quite, as much mechanical protection in there as possible is always good and safer for the customer. Yeah. There's a few of these functions aren't really worth going over in the MPPT range. A bit more specialised, just asking it to do particular things, and I think in a lot of the scenarios that I've been involved in, I don't think I've ever really used any of them except for the V Smart Networking. So the V Smart Networking, and this is a really handy thing in boats and some of the smaller systems, is you can get all the Victron systems that are smart to talk to each other without a GX device, without the thing, and you can limit charging. You can put a master in place of it. This one, as just an example, shows you that we've got the blue solar charger, and you can put it in range with the smart battery sense. What happens is when we set that up, is when you come into V Smart Networking, you create the network, you call it whatever you want to call it. It creates that network, and then it'll find all the devices that it can pick up on Bluetooth. It automatically adds them all together, and then you can set it to whatever you need it to be. So basically, in this scenario, where it works really well is if you've got charge controllers that are probably a little bit too far away from, or you've got to do a longer cable run for whatever reason, just because you have to fit equipment in particular parts in a boat. This can get really handy, because if you've got a battery sense, it bolts onto the battery, it's close to the battery, it'll Bluetooth its signal and settings back to where it needs to, and you're making sure that the battery's sort of getting what it wants. It's basically like a BMS in a lithium battery system. If you've got multiple chargers or multiple solar controllers, they'll all sync up and line up to whatever the master device is that's setting the system. So it's really, really handy. It makes sure that, like, if you have chargers or DC, if you have, like, as an example, smart solar charger and a DC-DC converter, and they're not all talking together, your solar chargers might be in absorption, you turn the boat on, the DC-DC comes on, is in bulk, and it starts throwing things out or pushing too much current. This talks between all of them, it synchronises them, they'll all be in the same charge state. Handy and useful. You can use it on house systems as well to make sure everything is just communicating and talking and falling into the right charge mode when required. But yeah, they're sort of the main ones that we use Victron Connect for, and the ones I'm most familiar with. The other one that we have in for smaller systems as well is the BMV battery monitors. They're probably Victron's biggest selling products. I'd hate to think of how many of these have been through our workshop at one point. Another really good device, the same thing, you can network them if it's the Bluetooth version. you can it can have a temperature sensor attached to it if it's the right model. There's really good, but it's a really accurate battery monitor and charger. We get the occasional installation error. People put the shunt in reverse. There is a particular way that the shunt goes, and you always have all your draw and load on one side, and you have your battery on the other. Or your draw and charging on one side, battery on the other, and the shunt will work itself out where everything is. You can also really get a really good display of kilowatts in and out, amp hours in and out, what your average discharge, all really good data if you're trying to look after a battery. If you have a battery that has a manufacturing fault, having this data is really crucial to send to them and go, hey, we haven't discharged it to below what you said, and we haven't overcharged it, and all of these bits and pieces, so you can use it to your advantage. Just on a few of the bits that I come across quite a lot in setting one of these up. Has everyone seen one of these devices before? Yeah. There's a few bits that people quite often get a bit lost in. I don't have the help manual on this one, but when we're setting all of these up, based on whatever your charge voltage settings are, the system, once it's hit all of these parameters that you've set in your system, that'll synchronize to 100% and make sure that the battery is exactly where it needs to be. Quite often what we find in bigger systems that have a shunt involved in them, there's a few little settings that we change quite a bit, which is the charge detection time. And the Pukit exponent is the other one that gets changed. So that 1.25 is just, it's charge, it's how much charge is going into the battery. It's a bit like an efficiency rating of what the charge is at, and quite often a lithium battery needs to be set much lower than 1.25 than what's there. But charge detection time is the other big one that we always see. 3 minutes is quite not long enough if you've got fluctuating loads being set up. Do we have any questions about the shunts or BMVs or anything like that, if you've come across any problems before?
How often do you need to synchronize the
You shouldn't. You shouldn't if it's set properly and those charge settings are right. The synchronization is just if it's been installed and some of those settings haven't been set correctly for it to synchronize itself, you can synchronize it to get it back on track. You might get a boat that you didn't do, it's not been set up properly, and everything's in float, and you know it's at 100% because everything's in float. You would if it's got that controller, you hit the two buttons, or you bring up the app and hit the synchronize button. Then you would go through and maybe have a look at some of those settings to just find out why it hasn't set itself properly. Yeah.
So what's the maximum time you should have in a float if you get in a boat? What's the maximum time on float?
I would be saying, I always leave the charge detection time probably, that's probably the one setting that we change the most, and bump it up to 10 minutes. So that means it needs to be sitting up on float for 10 minutes at whatever the charge voltage is that you've set, for it to go, hey, I'm at 100%, and then it'll synchronize itself. I know when we first ever started doing Victron, we used to use the synchronize button all the time, and things that eventually get out. And we eventually worked out that, the same thing. The more settings that you kind of equate it to, it should just do it itself. You should never need to touch it once it is set correctly. But yeah, that charge detection time is 10 minutes is usually better. Yeah.
One of the, because Fiji still used to those top ball batteries. We have 4 batteries being series. With the detriment, if one of the batteries burns up, and the other 3 is still in good condition.
Yep.
The detriment, see what's the reason behind it?
Not really. If you've got that bulging happening, could come down to, there could be multiple different reasons. It could be a manufacturing fault, could be cabling, could be a connection not done up tight enough, something that's causing resistance. In the battery monitor, what you would see, you can see all of those basic settings that have gone in, what's gone into the battery, what's come out of the battery, and whether they're getting what they want, low voltage and the high voltage. If you're getting bulging in a whole heap of parallel batteries, I would be saying it's probably a connection issue over anything, or if there's a problem internally in the battery, just maybe from manufacturing.
The balance help as well?
The balancers, I've never really dealt with them too much, the battery balancers, but I don't see them, they're not used a lot in Australia. That's because we don't have a lot of sites anymore that just use 12 volt batteries. It would help making sure every battery is at what it needs to be, but it's not overly crucial either, I don't think, to have it in the system. It's not, yeah. If you're going to add that cost in for putting the battery balancers and wiring them up, I'd be saying look at a different battery, or put that cost into putting a lithium or putting, something in. Yeah, yeah. I don't even know if we don't even keep them on the shelf in our, where we stock everything Victron, nearly every product we have on the shelf, but they're one that we don't. We order in because we just never really sell them. Yeah.
You often use the battery side, right? Battery sense.
Yeah, we use the battery sensors there. They go with lots of systems now. Especially our marine customers use them a lot, and the RV automotive caravan side in Australia is really big, and they use them a lot in the caravans as well. But yeah, the data, it's like, lead acid battery manufacturers, they're difficult to deal with. If you have any problem, it's usually quite a lot of information that they ask you for, to show them that it's not their fault, it's not our fault, it's a product fault. But they've been dealing with it for a very, very long time, and they can be very hard. Some of them can be very hard to argue with. Yeah. But having the data helps a lot. Yeah.
In saying that, the Victron failure rate is 0.6%.
Yeah.
Less than 1%. So if you buy something, it's the first time you buy something and install it and it fails, the odds that it's something wrong with the equipment compared to your install is pretty small. Alright, so these are what Victron judge the quality of their distribution is based on failure rate. So with our company, we know we're going to be at 0.6%. So if we sell something to you and your failure rate's up at 30%, then that has an impact. Right, so you've got to know what you're doing. This is important here. Don't guess it, just spend time reading and ask questions, as Kieran said.
I've had customers that we've cut off from Victron because their fail rate's too high. Yeah. So we've had customers that that haven't put the effort in, haven't done the bits and the stuff that they should be doing to make sure the systems work, and you'll replace something on RMA, and the next week that comes back, it's failed again, and you go, what, did you just put it back in and the bits, and it's the same faults happening over and over and over again, and the wrong tests, or they're not checking stuff, and it eventually gets to a point where it gets too difficult to deal with the customer. Victron as a company though, like with RMAs, are pretty unreal with what they will warrant and swap over. I've had customers that have blown up charge controllers by putting too much solar into them, and Victron will still replace it under warranty. They have been, not always, but they're usually extremely good. The other key bit to Victron as well is, in all of their big stuff, the difference is between what Victron do and a lot of their competition do is everything is really modular. The way they're built internally is really modular, so you can swap power control boards over, you can swap connection boards over, and you can swap the PCB board over in an inverter. You can do it on site. If you go through all the right trainings, you can actually get, and there's, like, you know, Solar VG guys, I did some training with them the other day showing them how you pull a board out. Some of it, especially with big inverters, you know, you can't send one person to pull this off the wall, you need two. Being able to do some of those RMAs and stuff, swapping boards over is a really big thing that Victron have up its sleeve. And it makes it really easy. Like if you do have a fault, they can pinpoint it and go, that's the problem. You need to change this board, you need to do these bits and pieces. Same with charge controllers, they're a bit more throwaway, but there's some really basic tests that you can do with the charge controllers to determine that they're faulty. And Victron are really good at swapping all of that product out on warranty process. You would have found they're pretty good here?
Yeah, pretty good.
Yeah.
We do everything quite good.
Yeah.
As far as their RMA procedures.
Yes, yeah.
We're all big on photo documenting every bit of the project, reporting on it. Not to the extent of Ciaram, where they're getting each 12-inching each battery, but that's a standard. Like he's arguably got the best company in Australia, and that's a standard which, I'd like to aspire to get there. At the bare minimum, you know, document all the program settings. Each customer's got to have a file, and then it's just a basic minimum. Every project should be cared for carefully and documented carefully. Photo documentation, reporting on it. So we're big on that. We're getting to that level, but still more to do, I suppose.
It's the more information you're keeping on systems. One of the biggest things that we find in Australia, and Australia came through, the way the solar industry evolved in Australia was, it came through with a lot of people that were not technical in the industry. They didn't understand. We had big government rebates that was like subsidising solar, and so what you would end up finding in our industry is it's taken a long time to kind of get there, but servicing of systems is really, really important. People don't go and spend, you know, $20,000 on a car and not service it. This doesn't happen, but people are spending that on their power system and putting it in and not checking it ever again. Like I say, whenever we're doing training and stuff with Victron, and tomorrow I'll go into it with how we go about it with our sites on our monitoring platform, but keeping an eye on your sites and monitoring what's there and selling that to your customer, and giving them peace of mind that someone's there and can look at the system is such a big, crucial part of it. And there's also, you know, servicing, there's money involved. You can charge a customer to go out, look at the system, give it an overview, check that the loads are all good. You can test the batteries. You can update all the firmware on the system and reprogram it. There might be features there to unlock. if everyone is on the same page with servicing and with selling that to their customers and talking about that from the start, it's beneficial for everyone. Systems will last longer, the customer will get better performance out of their system, you'll make some money. It's really key, the servicing side of it. I always stress it, because in Australia it was all about selling systems and installing systems and moving on to the next sale and the next installation. And I'm like, if everyone that you do, you know, you want that customer, you're tied to that customer for a really long period of time. There's like long warranties, there's upgrades, there's all these bits that happen with the customer. Just never lose sight of those bits, and servicing is a it's taken us a really long time to build our service side in our business in Australia, because none of our competition did it. So when you'd have that conversation with the customers, it's like, oh yeah, we'll sell you a system, and then we say, oh, you know, for X amount we can come back and, you know, be like whatever, it depends on where they're located, but it might be a few $100. Every 6 months we'll come and do a update. Maybe we do some modification to how the system operates, because winter to summer is really different in Australia. You can make all of those adjustments, and we can print them a report and say, this is how your system's performing. This is how your system's performing. Look, we've got some recommendations for you, like maybe put an extra 5 kilowatt hours of storage in, put an extra inverter in, because we noticed there's an overload here happening. It's just it's great for your business. It'll keep you in work. It'll keep, you know, there's that servicing side is really key. And if you start doing it from the start and everyone's on the same page, it makes it a hell of a lot easier, instead of worrying just about new jobs and sales all the time. Well, I'm probably at the end, if I like, before I jump into like really anything else. So have we got any like any questions in like particular systems? Like, if you're not happy about talking about them like in front of everyone or whatever it is, I'm happy to talk with whoever outside of here this afternoon or whatever. We could also, like, if tomorrow, if you want to talk about any of the issues, or like have a little break-off session or whatever, I think that could, you know, happy to talk any Victron problems that you're having. If I don't know the answer for them, I'll find out and I'll get you details and send you the answer.
If you want to write it down on paper and just submit it, and be sure to ask a question, whatever. Kieran can read the questions tomorrow. When do you want to have a think about it tonight? I don't know when we're going to get in here next, right? So take advantage of this. He's a busy man, and this is a golden opportunity if you want to ask any questions. Right? We don't know what we're going to do next, so.
Yeah. But yeah, I don't think I've until I get fully into stuff, but tomorrow, what I might go over, we'll go over the Victron monitoring platform and what you can do remotely in the systems. We'll try and chase, I'll get a cable so I can show you vconfig and 3-phase programming of systems, if that interests anyone, and just how we go about that start to finish. It's a big one that we get asked all the time, especially if you're really new to Victron. The programming side for those first couple can be overwhelming. But yeah, I think, and then yeah, VRM and monitoring platform doing things remotely tomorrow is probably what we'll try and cover off. I think that's what I've kind of gotten to. Covered GX devices. done that anyway. But yeah, and then I can probably continue on a little bit just with what Victron have in their pipeline and future stuff that's happening with the actual product itself. A bit of Victron's future roadmap of kind of what they're planning, you know. I think it's the perfect product for the islands. It's there isn't too many that are as flexible as this one, and for the system sizes that are really common here, it's pretty simple and robust, and same thing, easy to repair. All of those bits and pieces, all of that stuff is available to make sure that you guys are doing really well and putting these systems in.
Have you seen another company that's invested so much in the training modules within that?
Nah, none of them.
So let's say there's a couple of people out here that want to reach your level of expertise.
Yep.
And they have the desire and will to do that.
Mm-hmm.
Do you think just the available information contained within Victron, the training modules
Yep.
and everything, you think
I
if
think-
they have the will and desire,
Yeah.
they can reach
Yep.
a level
Yeah,
similar to yourself?
Yeah, I think the more, it's like all things, the more effort you've only got yourself to, you know, make it happen. It's not going to land in your lap. If you go and read all of Victron's documentation, they've got great videos. Guy Stewart out of Australia, who does a lot of the video stuff, is a really, really smart guy, and he, you know, he's been involved in Victron for a really long time. If I've got a question of Victron, he's my bounce off person. We always bounce questions off each other. He comes to me when he's hit up with stuff. But their training documentation is really good, and reading manuals if you can't, and the forum. I like a lot of a lot of having really good Victron knowledge. Or you can install the basics, and you follow those basic fundamentals. You'll get a system and you'll make it work. It's figuring out the problems when there is a problem, and you know. Where you guys work, where we work in Outback Australia, it ain't easy to call someone, even if they do have a call centre or a thingo, if it's one of the other competitors. Getting help, you know, you gotta learn it, you gotta soak it all in. So when you do come across those problems, that you know, you can work those fundamentals and put them into practice, and try and work out the system. The other few things that Victron do, if you sign up to Victron Professional, is you also have the log files when firmware updates happen, and I really enjoy reading. It's probably a bit sad, really, but I enjoy reading all of those change logs so I can find out what's new and coming in the product. You can also see the beta change logs because a lot of it's open source. If you Google Venus OS beta, it'll come up with the latest beta file and tell you, you'll be able to look through the log and see all the changes that are happening. And the most recent one, Victron are changing the color control and how it looks. There's a new display. Some of you may have seen it, some of you may not. Looks really cool, kind of really modern. But there's behind that, it's not just the pretty front page of the GX device that's changing. There's integration from all the generator manufacturers, more battery manufacturers, you name it. There's stuff happening, and it's constantly evolving and getting, you know, it's a very impressive set of, you know, a bit of software. So you keep up to date with all of those bits and pieces, and you just learn from keeping up to date. But yeah, solving the problems is the bit. But the more you know about the products and the ins and outs of it, and how some of the functionalities work. It's reasonably generic across all of the systems. So, and it's not just Victron either. A lot of the principles that you do with finding out and how all this stuff works, you know, an ESS battery or hybrid battery system, they all operate the same way. They all do the same things. They might call things slightly different, but fundamentally they're doing the same job. By really studying and learning those bits and the stuff that you have available to you for basically it's free. What is free? You're going to learn a heap from those guys, and yeah, that's basically what we did, was self-teach ourselves all of that stuff. None of the courses really, you know, that you know, you really go into the detail that you need to. So, yeah, cool. Well, I'm happy to answer any questions that anyone has, or if anyone's got any thingos, or if anyone wants to come up and talk. And yep.
So, the thing you were talking about the Victron professional, maybe is it possible to show them the actual?
Show what it is.
So in saying that, William's a guy who's our contact with the trades department. Right, lovely guy, grounded, humble. I think he's a black belt martial artist. But he's not pretending to be an electrician. So, but if you field questions to him, we'll run it through. We'll get a question back for you. But any of these learning courses, the Victron Professional, please go through William and he can help you out with all this stuff. And yeah, help you guys get along, you know?
So this is the Victron Professional website. If you do a really good job and you send it to Victron, your picture will go up on this bit. I've had 2 in my time doing Victron. Not of me doing work, just a job. But so this is the Victron Professional website. So they have upcoming events. So if you feel like going to France for a weekend and doing some training, or 2-day hands-on training in America. It gives you all of those things. Like quite often, Victron really slowed down in Australia with their training over the last little bit. They're slowly ramping it back up, but if you keep an eye out and you're going to go to they're behind with their Australian training, so it probably means that they're further away from here. Possibly, maybe not, but it might be. Just you can keep an eye on. So if you sign up, anyone can sign up to a Victron Professional account. Yeah, you can see any event that pops up. They also have like a news. They've got a new shunt that's out, which is a 300 amp shunt for smaller systems. They've also got all their latest videos. So anything from looking at their new battery systems and a big overview to the Class T power in and how it works and explained. You've got another one here, like this, like just in training videos alone, you've got smart rural electrification with Fronius and Victron. So if you're doing larger systems, Fronius and Victron work hand in hand with each other with power systems. They're running through a lot of their new Fronius technologies kind of changed in the last little bit. But there's bucket loads of videos in there. So let me click on the side. it goes on, and you can see examples of installations. Watch all of those bits and pieces. Watch, people have big time lapses of them installing hybrid generator webinars. There's all sorts of stuff. It's a treasure trove of information. You also get access to Victron's blog. If you do anything that's like Victron love the islands, the photos, the place, the story, like they love it to bits. If you are doing a job here and it's a cool job, like you want to get put in touch with Victron and promote your business through their blog and on a national, an international stage.
Send it through to Ashna.
Yeah, send it to Ashna.
We'll promote your company through through the world, I suppose.
I've been in there 4 times. A couple of projects that we've done in the outback, and the winery. My name must be in the Vanuatu one there somewhere. They're online training as well. So these are like product specific trainings. Most of them are done by Guy Stewart, who runs Victron's training program, or comes up with the digital side to their training program. He's actually a really, really clever guy. He came out of Rainbow Power Company in Australia. And there's also like, what do you call it, like little courses and tests and bits and pieces that you can be doing as well.
So you get a certificate for every one of these. So if you've got running crew,
it's a great way. We put all of our apprentices, even new electricians that come on, go through all of the courses so they can take it all in and have some understanding of it. Helps. The more that they're reading, the more that they're seeing and taking it all in. There's nothing, if you're doing it in your own time and you've got time to soak in what you're looking at and what you're doing, one of the big things that I always find, and I even find it with our own crew back in for my own business, if we've got guys that don't take the time to be putting the effort in to learn this stuff, not in their work environment, if you're waiting to the end of your job when you've been working all day, carrying panels, lifting batteries, putting stuff in, dealing with problems, digging trenches, whatever it is, you're exhausted by the end of the day. When it comes to going, it's time to commission the system and turn it on, and you're hoping that it's going to sink in, especially if you're not experienced doing Victron. You just don't retain that information. And so sitting down, even if whoever you're working for or whatever, I always find it's really important, set some time aside, study, do those bits, soak it all in, take it all in, and then when you are at that point when you are tired and all those bits at the end of the day, you'll be able to just get through it. You'll know things will just happen. You'll be able to program quicker and get out of there. As soon as you have problems with program, I watch some of my guys all the time that operate like that, and they get to the end of the day and it'll be a simple problem becomes a big problem because they're tired and they're not thinking straight. One of the other things, if you've got a laptop set up with all the Victron software, it's kind of really important to get, and I always say just sign up for a free Dropbox account. Install Dropbox on your computer, and you can set up the firmware files to automatically be dropped into your computer. So if you download Dropbox, it's a really handy thing to have, because if you get all the way out to site, every time your computer then is connected to the internet, it'll download all the latest firmware files, deletes the old ones, so you've always got the latest with you at every opportunity. Super, super handy. It just means you've got them on the computer all the time. If you have no internet, you've got them. You can do all what you need to do. If you do have internet and you don't have the Dropbox though, you can dial in to this portal and you've got access to every device there. MPPTs, shunts, anything that's got firmware on it, it is listed here. So you would have all the processors, all the bits and pieces, depending on how that is. I can run into a lot of that tomorrow with how you go about firmware updating an inverter when we look at this other software. But you can see in here as well as you've got the change logs for all the different particular parts of the inverter. And like if you're having problems, sometimes, you know, a lot of times it's a firmware update that can fix it. It might be a known glitch or an issue that's happened with the way that you're trying to operate the system. Yeah, it's really handy. Sometimes the change log is where, you know, the solution to the problem is. There's also in here the repair documents. So you can actually set this up so this will give you all of the instructions if you were on site and you needed to test. They're bench test instructions, but a lot of the instructions can apply to you on site as well. For MPPTs, inverters, it'll ask you to do particular tests with your multimeter just to make sure that it's not an issue, the actual product itself. If you're building a website, doing any of those bits and pieces, you can get, Victron have a lot of stock assets and product that you can actually pull, you know, pictures and images for marketing material, and that's basically it. The rest of mine's for developer and e-order. The only other thing in there is the news of telling you what's actually happening with Victron and the toolkit and the GX devices. Really handy to see what's happening basically with Victron and the latest product updates. Yeah.
Yeah.
Yeah, I'll go into AC coupling and assistance tomorrow. I'll do the ESS assistant tomorrow and how you program that all up and run through those bits and pieces. All good? Yep. Should we get everything started and underway? Is everyone here? Morning, everyone. Hopefully, you know, I said to Tony at the end of the day yesterday, I felt like I rambled on a lot yesterday and talking about lots of Victron stuff, and it's amazing once you get started talking about all the bits and pieces, how much actually you realise how much stuff there actually is there to take in and learn about this product. This morning I might start with just running through. Yesterday I kind of gave a little bit of a brief overview of Victron Connect and how you program and set up using Victron Connect. It's a really simple way of doing really basic and simple systems. It's all there on your phone or your computer in the one app. You can program all the devices and the layout is pretty similar for all devices, so it's kind of quite easy to get your head around. The sort of level up to that, when you start getting a little bit more complex with systems, so you've got AC coupling involved, you've got a grid connection, and any of those bits really, you need to start looking at using a program called VE-config. So I'll do a bit of an overview of how VE-config works. Again, you need that MK3 dongle to be able to access it, and it only works with the Multi-Plus and Quattro inverters. And it's basically a lot of the same settings, but there's some more advanced stuff that we can do as we go about setting it all up. There is also another program that's involved with it, which is called vFlash. vFlash is a firmware update tool. If you were using Victron Professional and you need to do an update on the inverter, vFlash is your sort of first step. One of the things to remember when you're updating Victron firmware is it wipes all of the settings on the inverter. So it's something to remember. If you get asked by your distributor or someone, go and update the inverter and test it, make sure that you've downloaded and saved the actual file first from VE-config, then go and update, and then just re-upload that setting. But I'll show you how that all kind of plays out. Now I don't have an example inverter to kind of run you through, but vFlash is a pretty basic tool. When you're in that Victron Professional portal, you can actually find the firmware versions for each of the inverters. Does anyone know how you figure out what the firmware version is of the inverter? Nope. So there's a couple of ways that you can go and find that number or the firmware version that's currently on the inverter. So one of the first steps usually is there's a couple of ways you can go about it. If you take the top plate off of the inverter, and hopefully I've got a photo, I'll try and dig it up in a sec, but if you take the top plate off, there's a processing chip that's right in the center of the board, and it will have a 7-digit number on it. And it usually pretty much everything you'll see around here, unless it's American, it'll start with a 26. It'll have 2 other numbers, and then it'll have 3 numbers at the end, and the 3 numbers are what it come out of the factory as, with what firmware is on the device. So if you don't want to take the cover off, when we load up VE-config, my computer's going a bit small, that's a bit slow. You'll plug your MK3 dongle in, you'll plug it into the V bus port on the inverter, and then we do, if it's all working, you should be able to auto detect that MK3 dongle. If it doesn't work, it'll just keep going through its cycle and time out. If you've had trouble connecting an MK3 dongle before, the first time that you ever plug the MK3 dongle in your computer just to check that it connects, it's really important to be connected to the internet at that time. If it wants to do an update, if your computer needs to download a driver, it'll automatically do it in that case. If you're on site and you've never plugged it in or never used VE-config before, you can have quite a bit of trouble. We have quite a bit of time talking to people how to download the driver, and after the auto download has kind of been finished. So make sure you've tested it before you leave the site, and it's all connecting and talking to your computer. Once it's doing that, you would just hit auto detect. It takes about a minute for it to connect, and you'll see it sequence through all of the options and all of the bits. I'm just going to run you through the demo version of a VE-config file, just to kind of show you through it. When we were looking for that firmware number in vconfig. Once you've connected to the inverter, this, where are we? Sorry. Once you've connected to the inverter, you can hit target, and you can get and send settings. You can show a panel that brings up a few more details about what the inverter is doing, but you can also hit show software version. When you hit software version, because this is a demo, it's showing 0. Normally that would be a 7-digit number. Any of these documents, it's kind of, we have a lot of this stuff, and Victron have a lot of this stuff written into PDFs. If anyone wants any of the documents that kind of pull all of this information out, I'm happy to send it to you afterwards. So you would see that software version, you find it in the Dropbox, and then you can go back and do VE Flash. When we're going through all of these tabs, basically the tabs are very similar to what was in Victron Connect that we ran through yesterday. All of the same settings are there: the AC input, hertz, battery monitor, the grid settings, whether or not you need a grid code, and you'll need that for some of the assistance. Your inverter tab, which has a bunch of inverter settings, your low shutdowns, your cut-offs, your power assist settings, charger is all your charger settings, your weak AC input that we discussed yesterday, and whether or not that you're in a fixed lithium battery state or still using AGM gel batteries. There's charge curve and absorption, repeated absorption times that you can set in that. The difference between vconfig and Victron Connect, and where you'll need to use vconfig, is if you're AC coupling solar. If you're AC coupling solar, there's we end up having to use what they call in Victron terms assistance, which is basically just its own little very basic control logic to make sure that that AC coupled inverter is frequency shifting to work. So if you know what an AC coupled solar inverter is, it's when we build Victron systems, occasionally we will use either a Fronius, an SMA, grid connect inverter that sits on the output side of the system. And there's some benefits of using AC coupled solar, especially in hot, warm environments. It's quite good at taking heat away from the inverter during the middle of the day. It allows you to surge up and over the capacity of the inverter during the day if there's solar available. And it's really handy when you're doing mixtures of DC coupling and AC coupling, especially in larger systems. But the way that Victron controls AC coupled solar is via frequency shifting. So it's what we call frequency dependent power control. And what it does is as the solar starts producing and the Victron doesn't need it, it ramps its frequency up, and on a linear scale, whatever we've set the range to be, it'll ramp up the ramp down the solar as the frequency rises, and it basically manages itself based on what it needs to do to supply the load and charge the battery. When we go through and add assistance, people it can get quite confusing when the first time that you've done this. Sometimes I always think that they should have PV inverter support just on by default in assistance, because it would just make life a lot easier. But you come in here, there's a list of a whole heap of assistants, and some of them I'm not going to bother delving into, but some common ones that we use in projects and systems that we install, we use ESS, which is installed when you're doing grid connect hybrid systems. We often use the general flag, okay, like to ignore, and you use that to ignore AC inputs. For whatever reason, you might want to do that. If you have a simple system that doesn't have a GX device, you can use the generator start stop and use relays from inside the Victron inverter. PV inverter support, which is for AC coupled solar. And then the other main one that we use a lot is the programmable relay. And programmable relay basically gives you a huge range of different options to be able to switch certain parts on, or switch certain relays on and off within the inverter itself. Yeah, but the main one that everyone sort of always asks about is PV inverter support. When you're installing the assistant, you have to click on it, and then we hit Start Assistant, and basically it'll run you through the steps that you need to set to make sure that power control is working. What you also need to find out is, it depends on the solar inverter that's attached with the AC coupled solar inverter that you're trying to connect into the system. If you're trying to connect with Fronius, that's a really easy combination. Fronius and Victron work really closely together and have for a very long time. So all the default settings that are set in PV, the assistant, they're all set for Fronius inverters straight off the bat. If you're using SMA, which you probably come across a bit here as well, SMA runs on a skinnier frequency set, and there's a manual on SMA and frequency control that you can get the range, but it's slightly smaller than what the Fronius is. So you just got to make sure accordingly that when you run through this, that you know what the inverter is, the AC coupled inverter that you're using is, and you also need to make sure that the frequency lines up with whatever window that the inverter has. So when we step into the next bit, it'll just ask you whether there's a V bus BMS. Unless you're using Victron batteries, there won't be. We have a voltage to restart the PV. This is just a safeguard. If the voltage drops extremely low, it'll kick everything back into gear based on whatever that voltage is set to. So you can set that quite high just to make sure that the PV kicks in when it should. The thing that they bought this setting in for, it's only been recent that they've bought it in. Frequency power control has the shortfall that you can have with it is if you have a window where the system falls back into a bulk charge after it's discharged slightly and the AC coupled solar ramps up, and you could have clouding effects and bits and pieces like that. You have the potential that you can feed a lot of energy back into the battery before the frequency winds it down. And so they introduced this setting to stop that from happening. You can make sure that the PV inverter won't kick back in until the battery voltage has dropped down low enough that you're not going to cause any damage. The next one's the frequencies. So this is what I was talking about, the power control. On this one here, so it basically steps you through it as you go, but the solar converter will start reducing output power at 50.2 hertz, which means that's where it starts taking control of the actual solar inverter. If the site's at 50 hertz, it means the inverter's open to be doing full power. As it doesn't require that power, it'll push the frequency up to 52.7. And as it pushes up to 52.7, the solar will come down to an absolute minimum. And then once we get to 53, that means that the system will turn itself off and stop the Fronius from, or the AC coupled solar inverter from working at all. It's important to tell the Victron system as well with PV, like with AC coupled solar, how much solar is actually on it. When you're AC coupling with Victron, they have there's a few rules that you've got to follow, but the main one and the one to stick to is the ratio of AC coupled solar to the size of the inverter. So if you have a 5 kVA or a multi-plus 48-5000, you can't install any more than a 5 kilowatt inverter on that multi-plus. You have to 1-to-1 is the ratio. So and it's always been like that. If you install bigger, you just cause overloads. The system won't like it, and it'll shut itself down. There is ways around it. If you have an inverter that's slightly over, as an example, if you had a 5 kilowatt Fronius and you had a 6 kilowatt in a 48-5000 multi plus, and then you had a 6 kilowatt Fronius that was already on site, you can actually hard limit those inverters to make sure it doesn't go above 5 kilowatts. But yeah, what we do there, install the inverter PV power and then the panel power as well, so it knows how much it's got in the tank basically. Once that's sent or finished, and we've set all of our other settings in the system, you've always got to remember to hit send settings. When you go to send settings, it'll send all the settings to the device, and then it'll come back and it'll ask, do you want to send the assistant? When you send assistance, whatever it be, a programmable relay, any of the bits, the inverter will shut down and send the settings, and then it'll restart after that. It's kind of important to know that, so if you do make any change, even if you open an assistant, it'll ask you to do that reset. Quite important if you're doing setting changes or changing stuff on existing customer's house and they don't want you to turn the power off. Yeah, to run through just a couple of the other assistants that we have. Another really key one, and I know the Solar Fiji guys had asked me about it quite a bit. It was using programmable relays to switch particular parts of the inverter on and off. And one of the key ones, and if you've worked with Victron a bit, you would have seen that there's 2 AC outputs on the system. That second output you can use to control or to load shed based on conditions that are happening with the inverter. The load shedding is like, we use it all the time for hot water services, so we can try and switch them on during the day and not have them on overnight, and bits and pieces like that. We could be like, load shedding particular equipment or a shed or so, or whatever it wants to be. Whenever you're setting assistance, you always need to make sure that whatever you tell it to do, especially in the programmable relay sense, is when you tell it to turn on, you also need to do another assistant to tell it to turn off, and what that reason is that you're turning it off for. So, as an example, if we were going to do use that AC out to control a hot water service, and I want it to run when the battery's pretty much full, I don't want it to run overnight. An example of that would be, we'd load that programmable relay, and you'd say, use AC out to relay, which is turning that output 2 on and off. You would go next, you would say set the relay on to turn it on, And then you get a whole bunch of settings in here that you can use to control it. So the main one that we would use would be state of charge in this scenario to turn the hot water service. We just want to make sure we can have the hot water service on when the battery's full, but we don't really want it on if the battery's starting to discharge. So as an example of that, you would hit state of charge. There's a couple of extra drive options here, but we never really use them. And then it would just ask you, drive that relay and turn that feed on when state of charge is lower than, or sorry, we want it on when it's higher than, let's just say 90% state of charge. And that's done. You would load another assistant and put it back on, start assistant again, and then we would go and run through the same motions. You would select AC out to relay and then set it off based on state of charge when it's lower than 90%. You send the settings, and then you basically got a load shedding control in the system. So you could use it for whatever you want. It's like hot water is just one that we use it for quite a bit.
So in the village setting,
Yep.
if you have the deep freezer,
Mm-hmm.
that'd be perfect for it,
Yeah.
yeah? Any excess electricity,
Yes.
throw it into the deep freezer.
Yeah, exactly right. Yeah. Yeah. Anything that you don't want running and pulling on the battery at night time, it's a really handy feature to have. Like in Australia, we have a trend at the moment of like like tiny houses, and they put them in remote locations, and people rent them out and have a farm stay or in a winery, and they'll stay right in amongst the vines. What they find is they put quite small systems in there, and quite a lot of these little houses are quite luxurious when they're there. So when we build them or put the power systems in for them, we quite often put the air conditioner on there as a safeguard, because they don't want to run out of power. The houses are small, like they're easy to cool, but what we find is if they, you have people that don't necessarily live off grid, that don't care that it's off grid, and what they would do is leave the aircon on, go out for the day, all of those bits and pieces, and we use it to switch the aircon off. If the battery gets to say 30%, load shed the air conditioner to make sure they've got enough power until the morning, and the sun comes up, and it is really handy feature just to make sure that your system, you're protecting your battery, you're getting longevity out of what's been installed there. So that's basically the config in a nutshell. Do we have any questions, or has anyone had any issues with the config?
Can you use the same settings to on this platform?
Yeah, you can. So that's if you I always say the if you're doing a system that needs to auto start a genset and you've got a GX device in place, it's always better to do it from the GX device, because it gives you a bit more control over what you can start and stop the generator on. But when you can still do it from the inverter as well. We've had it, we quite often do systems in Australia where we have a two-phase grid supply, and then we build a three-phase system around it, and we use extra inverters to bring in and out the grid, and we always use the generator start stop assistant. So to kind of just run you through that quickly, there's a generator start stop assistant. You can use any of the relays that are in the inverter. So when you've got that bottom plate off, on a Quattro, you can see them all. They're just underneath where the DC connections are. On a Multi Plus 2, they're kind of tucked up, right up in there. You can use any of those relays to start and stop. You just have to choose it. But if you use the primary one that's there, you close the relay to start the generator. You can choose a few conditions there, load. If you wanted to, you could choose start on battery voltage, low state of charge. You can also set a minimum runtime for the generator. Once you select them, each section will come up with, each section you'll have all of those 4 bits that we just selected. So this is the load, start, stop, and it has to be over X for 10 seconds or and then under for 60 seconds to turn it on and off. Battery voltage, same thing, temperature compensated, battery sense. You can also just put it on DC input, you don't have to use the compensated version. State of charge, whatever you want to set that to based on the battery. And then you can set the stop condition in there. So when it's, so basically battery voltage higher than what it needs to be, any of those you can select. You set all of the stop conditions, minimum runtime. You can also set whether, as an example, like we did a system that had EFL and generator the other day. You can say once if EFL goes down, the battery goes flat, and then the generator starts and brings the system back to life. If it's still running and EFL comes back on, you probably want to turn the generator off and just let it sink back. You can set that if whatever AC input EFL was set to, you can make sure that once that becomes live again, it drops off the generator. And then once you've set that, send the settings, and that's all done. So you can use the K1 relays. If we're going to do it, this is probably the one to use, but there's a programmable relay in there as well. Yeah.
So with that setting,
Yep.
you can use that occasional jigs
If you didn't have a GX device, that's how you can stop the generator. Yeah. The reason I like, if you have a GX device, it would be preferred because it's visual and easy, and you can make adjustments a lot quicker. If you need to make an adjustment on this, every time you make it, the site shuts down and starts back up. That's the main reason. And you have to dial into it and get the settings and all of the stuff, whereas you can just touch the screen. Yeah.
My question would be based on compatibility.
Yep.
Product compatibility. Given the PGM context, how compatible is Victron with other products? Availability, like here in Fiji, there's a lot of Chinese products as well.
Yep.
In this instance, and my question is, there's a few factors that could happen.
Yep.
Given finance one in a remote setting.
Mm-hmm.
And how compatible is Victron? Say for instance, you have a Victron inverter, and then MPPT is a Chinese product, and the battery. How compatible, or what's the red flags to it?
It's because it's so modular, and they've got it's not an all-in-one. They've got different bits. It's really compatible with a lot of stuff. It's one of the most, and from its GX device and what they're integrating into the GX device now is even more compatible. So what they've tried to do, and there is some Chinese product's a little bit tricky because sometimes it's hard to work out whether their spec sheets actually says what it says it can do. But what Victron have done, so there's some international standards, like with AC coupled solar inverters. So if you had like a SunGrow or they're all compatible with Victron. You can get them to talk and integrate. Solar Edge, SMA, GoodWe, all of them can be integrated into the Victron platform. They need to be able, the sort of key bits in the AC coupled solar side, they need to have just to be able to frequency power control. If they can do that, then they're good. Even better if they've got sun spec data, if they use the sun spec Modbus profile. Any sun spec inverter, Victron can read the data from and display it on its GX device and show you what's happening. If you're like third-party MPPTs and all of those bits as well, like you can make them work with Victron systems. If you've just got a really basic simple system with an inverter and an MPPT, you might put a Victron battery monitor in so you know what's going in and out of the battery. We see lots of those systems. The bit with Victron is it's just getting at if you the sort of level up your systems when you're using the GX device. Some of those MPPTs you can't see on the device, so it skews the data that's coming through. There is ways around it, like you can put shunts on, like Victron shunts on the MPP, the third-party MPPTs, and say, hey, this is a solar controller, and feed that data into Victron. But as compatibility goes, like if you had a failed Chinese inverter, swap it for a Victron. It'll work as an inverter. And do what it needs to do. So it's not really affected too much by third-party bits and pieces. You get some really good benefit of slowly switching them over fully to Victron because of that GX device and its monitoring and all the bits and pieces that you can dial in and see. But if you're coming across systems with Chinese stuff that's failed, there's plenty of options. Just either keeping it basic or getting it really advanced as well. And the guys from Solar Fiji can help with piecing the parts that you need for that stuff. Yeah. Does that sort of answer a little bit?
What about lifespan?
Lifespan?
When integrating that sense.
Yeah, so lifespan on all so Victron comes as standard with a 5-year warranty. You can extend it to 10 years. We've got like I've got 500 installs on our monitoring platform. Some of those systems are like 12, 13 years old. We've been like a distributor for Victron for a long time now as well, and we see inverters that come in on boats that might be 15 years old. It's like all electronics, and there's always lots of things that can go wrong and pear-shaped and cause damage or cause you have a crooked battery. The battery might be crooked, but it can also put strain on the inverter. And the other thing you've got, if it's connected to the grid, you can have surges and all those bits and pieces. But the thing is, Victron are extremely good at warranty, and there's the warranty side of their business. The other bit with Victron inverters, just in particular, each inverter basically made up of 3 boards internally, and they're all repairable. So like you can pull, particularly if something fails in a Victron inverter, it's not here's a new one. The board gets pulled out, a new one gets slotted in, and off it goes. Those boards haven't changed. They've been the same in their products for a very, very long time now. Yeah, but lifespan. I would expect anywhere from 10 to 15 years would be the would be the lifespan, but we've seen it go longer. Just really site dependent.
I have a site, a Victron site.
Yep.
Which is 18 years old.
Yeah.
And it's in a humid environment in Honolulu.
Yeah.
Still running today.
Yep. Yep.
I sent the photo to William.
Yeah. Yeah.
One of the old.
Oh, it's awesome. Yeah. Yeah.
The 350 var
Yeah.
on the old.
Yeah. Yeah. Yeah.
It's 18 years old.
Yeah. Yeah. Crazy. 18. Yeah, we've seen some really, really old ones come through the workshop before. We had one guy that hasn't missed a beat ever, and he thought he came through. He had one of the first Winnebagos, like big travelling vans, and had a Victron inverter in it. And he came in. He goes, "Oh, I probably been in there. I reckon that was 16 years." And he came in. He goes, "Oh, can you do a service and a software update on it?" And I was like, "Oh, we can't software update these anymore." I think he'd been reading the Victron blog, and he's like, "Oh, there's some really cool things that are happening. Can you do an update?" I was like, "Nope." But yeah, still working. Yeah, yeah. And it probably gets down to a little bit as well, that longevity. Like if you're building things, putting them in the right environment, building your rooms right, making sure that they're quite sealed up. Like, you know, probably the biggest thing when failures we see, like the inverter's quite open. Like in Australia, I've seen everything from like lizards to snakes. The craziest one was a bat that had crawled into the inverter. You know, we've seen that's a big cause of failure. But if you're building your rooms right, you know, you can stop a lot of that quite well. And if it is an environment where you can't stop a lot of it, you know, we quite often make up our own little sets of grills and bits just to try and stop that from happening. But that's probably the thing, the biggest killer to life of the system, I would say. Is that, have you guys found that a problem here? Yeah. Yeah.
We build pages as well.
Yeah.
Stuff getting in.
Yeah. Yeah, it's a really, it's the reason you get asked about it a lot because there's other products in the market that are quite sealed up, but they're quite big and bulky, even though Victron's quite big and bulky. But the thing is, it's all about airflow. So it's the more air they get over it, the cooler they can keep it and keep it producing the power that they need it to do. You quite often find that when you're looking at Victron inverters and you're seeing surge ratings and continuous power output, they kind of rate their product a little bit differently than some of the competition. Some of that competition, like SMA and Selectronic, are actually, you know, a transformer's a transformer. They do all of the same stuff, but they can rate them differently to kind of show the ways that they operate differently. And you know, I always get asked, "Oh, you know, Selectronic has much better surge capacity than Victron." Well, Selectronic is a bigger inverter that they call a smaller inverter, and so when you're looking at all of those spec sheets, it's just trying to read through the lines of, you know, they're all doing the same thing, just how they draw them up on a spec sheet, really. Have we got any more questions about vConfig at all?
One question.
Yep.
Regarding the systems for the AC couple on
Yep.
the input and the output,
Yep.
are they quite the similar setting as this one?
On the input and output, you don't need them on the input. Yeah, so that's when we do ESS. So which I can run you through. I could run through some of that. That's probably just the other assistant quickly just to run through. If you're doing a system that's connected to EFL, just delete. And you've got AC coupled solar, and it's grid connected, you need to have this assistant, which is called ESS, which is basically turning the system into a hybrid. when we select it, it'll start, but it throws an error because I haven't selected a country code yet. When you go back into this grid tab, you'll see here country code and grid standard. With ESS in Fiji, I'm not 100% sure of what EFL's parameters are, but the easiest way would be just to select the grid code as other, and it allows you to select your own windows of operation that it can connect to and work in. There's two options. Victron in Australia, they followed two different standards when they kind of started programming this up, and they did a UPS standard, and then they had to follow the AS4777 standard, which has made things quite difficult, and it caused huge amounts of confusion. And it's all to do with electrical wiring of a switchboard and neutrals joined or not joined. And where it got really messy was you'd have some inspectors in Australia that would say it's fine as the original way that they had it, and then others that said you can't have the neutral splitting. So most sites we select this one that says AC neutral path externally joined. Once that's been selected, it runs you through just a double check to make sure that it's okay. If you stuff up and choose the wrong grid code, there is a password that you require to be able to change it again. If you need it, you just talk to your wholesaler and distributor to get that code. Once you've selected that, we have down here AC input 1 and AC input 2, because we're talking about a Quattro. The site that I went and looked at for Solar Fiji, we had a generator on one input, EFL on the other input. Victron have some settings in here, and they call it loss of mains, and it's a sensitivity thing for grid connection to make sure that the site, if there is issues with EFL, that the site drops out in very, very quick time if there's anything goes wrong. Grid connections are really fine to keep loss of mains on, but if you're doing a site that has has a generator attached with it as well, loss of mains is terrible. It'll never connect to your generator. The generator, when the site closes, will wobble, frequency wobbles, doesn't like it, and it'll disconnect. In that scenario, whatever input that you would put your generator on, if you're doing a generator and grid system, make sure you just disable loss of mains. It still flicks off, it's still safe, it still turns everything off extremely quick. It just takes the sensitivity away when it connects. Once we've set that grid code, we come back to the assistance tab. You would go into ESS, start assistant. It kind of gives, each of them give you a link to the manual on energy storage systems. If you're doing grid connect stuff, I highly recommend working your way through that manual, because that manual is really explanatory over how ESS works, the different ways you can make energy storage systems work with Victron. It's like a 2-day course basically on its own. Victron also have a couple of videos on their training program on it. But yeah, it's quite a big area to go into. When you load up the assistant, it gives you the requirements. It tells you basically what this assistant does. When we go and set it up, it'll ask you for a battery system and what type of battery it is that you're using. Most of you will probably be using, I imagine, like either a gel or AGM battery, which you can select there, or you'll be using a Pylon Tech or a BYD battery. And in this, this is an example, I'll just choose that option. You set your battery capacity in there, whatever that may be. There's a setting here which is V-configure battery type selection. And so if you change battery type as suggested, which is a setting, it goes through and adjusts all your settings that you've made to some defaults. And those defaults may not be what you've gone through and set up. So quite often you just go do not change as battery type. If you're using like a managed lithium battery, like Pylon Tech, BYD, ZYC, BMZ, like any of them, most of them have guides on Victron's website. So there's a list of supported batteries that's there. If you Google it, there is a guide on that battery, how many batteries are a minimum on each inverter. It'll tell you what battery charge settings you need to enter on each of the devices. And it's really handy. So if you're using anything, just give it a Google. And as like an example, like you would go Victron Pylon Tech. The first thing that pops up is its live battery compatibility guide. It comes in, these are all the Victron, these are all the batteries that currently work with Victron. Voltages, minimum firmware versions, and then it gives you the big explanation of how you set it, the minimum battery size recommendations, tells you about dip switches, the type of CAN bus cable that you need to use. It really goes into some really good detail purely on how to set that one battery up. And that same guide is there for all the batteries basically. So if you come back into the battery compatibility list, these are basically all the ones that Victron have given their tick of approval to. They're not the only ones that work. There's other ones in there that work, but Victron, because there's so many battery manufacturers in the market now, they're very they try not to put too much effort into trying to give everything that comes to them a tick. They kind of leave it up to the battery manufacturers themselves to prove that it works. But yeah, you have everything in there from Battleborn to Discover and Excite and Pylon Tech, BYD, all the main ones. They also give you a guide, like there is third-party BMSs that people have, and they also give you a disclaimer about working with particular types of battery that may say that they work, but they may not work. So when you're running through this, we have a few settings in here, like sustain voltage. Just another thing, if the battery's been left in a low state of charge state for a period of time, it can fall back into and push the voltage up from that point. Any of these that you need to go into more detail on, or you want to actually understand what it is that you're actually setting, there's manuals for all of it. You can find controlling depth of discharge and all of those bits there. We have dynamic cutoff. It's one of the settings. If you're using lithium batteries, that is a bit redundant. You kind of set these dynamic cutoffs to be not working in the system because it's not required. If you're using, they're mostly designed around gel and AGM batteries. We have a restart that allows the inverter to start inverting again if the battery goes flat once the battery voltage rises back up. And then the same thing, basically the PV inverter assistant is built into ESS as well. So if you do have a Fronius inverter or AC coupled inverter attached to the system, you can set that all back up exactly the same as PV inverter support. Once it's sent, same thing again, send the settings, the system will shut down, start back up. That means you know you've done it correctly. Has anyone here done an ESS system on Victron before? Nope.
So, can I use it for ESS?
Yeah.
It's for the AC unit.
Yeah, it's for that.
For the AC, okay, that the PV inverter.
Yeah, that's it. Yeah, yeah. So yeah, when you run through ESS, if you do PV inverter support, it's just a part of it. You tell it there's an inverter going to be on the output, and then you step through the normal routine of setting the frequency shifting. Once that frequency shift is set, the difference is if you have it on the input, you need something to measure. So you need an energy meter or something like that as a part of an ESS system. Yeah.
And which is just when you generate.
Yeah. Yeah.
Yeah, there's obviously a lot to digest here,
Yeah.
and I doubt everyone would be absorbing it all. How would you recommend a technician will get familiar with all these settings and kind of practice?
Yep.
And gain information through the Victron portal
Yep.
regarding programming.
Yep.
So they can become comfortable with it
Yep.
without actually damaging
Equipment.
equipment.
Yeah. So all the Victron programming software, you can load a demo file. You can dial in, play around with all your settings, have a look, have a read. It'll take you to what you know. Everything in this manual, like or in vconfig, if you right click on it, it'll come up with what is this. And then it goes into bringing up the help file, and it'll explain to you exactly what that setting means. Every setting in there has a definition, what it does, why it does it. A little bit of it's written in Dutch, not in Dutch, but like Dutch English, and it can be tricky to try and digest. But that would be the first step. The second step, if you're delving into ESS, is just reading through the Victron manual. There's also a really, we're going to do like a 2.5 hour, 3 hour webinar on ESS systems that talks about grid connection, how you can integrate it, and all the different control stuff that you can do. But it would be the same thing, going back through Victron's training on the Victron Professional portal, stepping your way through those bits, and then whilst you're doing it, looking at the actual program itself is what I'd recommend. Yeah.
Can you walk us through parallel setup for using Victron?
Yeah, so it's another one that we get asked about a lot. There's a couple of ways to go about it with Victron, and the I've done it the same way that I've always done it, and because we do small systems, large systems. There's two other programs in Victron called V-Bus Configurator and V-Quick Configure. A lot of people use V-Quick Configure. I never do. I've always stuck to V-System Configurator. We also do a lot of bigger systems more often than not. So when you're setting up parallel inverters and you've got all your cabling right, you've got your daisy chain happening between the inverters, the first step, and I'll run it through VBus configurator because it's kind of the easiest and visual one to make sense of. What we would do is you'll load up VBus. Have you seen VBus configurator before? Where are we? What I'll do. I'll turn on. Sorry, hang on. I'll turn this on. So as an example, I've just shown this in demo mode, so I'll show it as if you're plugging two inverters in for the first time. You would select COM port, you go auto detect, it goes through its searching process and doesn't find anything. Let me have a look here. What is that not working for? Oh, sorry. I know what I'm doing. Hit the wrong button. Yeah. Once you've kind of set up, so yeah, plug your two inverters together, connect to it. You would go get configuration. It's not working either. Sorry, it's a little bit trickier. It's probably harder doing it this way than doing it on So here's an example. So what happens is once you've searched, you've found your inverters, you would come down and set what system configuration that you want. So if you're putting inverters in parallel, that'd be in a single phase. You select OK. You come up here to your unconfigured devices and you just drag them in accordingly. Drag them in accordingly to what you need there. Once you've kind of set that, why is that? Once you've set that, what you then need to do is send that configuration to the device, which it isn't doing. Hang on. Let me fix this. Yeah. Sorry. So once you've configured and you've dropped your inverters into whatever phase that it is, if it was 3-phase, you select each one and drop it into the phase accordingly. there's a couple of bits that you can always do as well. If you right click on the system, go flash LEDs, and the inverter that you've selected will flash like crazy. So you know, not as important when you're doing a single parallel system, but if you're doing 3-phase, you obviously want to know which phase is red, white, blue, or line 1, 2, 3. So it's handy to do that flash LED. Once you've kind of dropped them in on that line 1, you send the configuration to them, they become active, your inverters will turn back on, and then they'll be parallel matching each other, doing what they need to do. That's the first basic step. Once you're done that, you then need to right click on the inverter, and then you just go into vconfig multi, which basically loads up vconfig. Takes a few seconds. And then you're into the system. So you would set it up as per normal. Once that's been set up, there's a couple of tricks when you're doing parallel systems or 3-phase systems. Your basic settings in these first 5 tabs. Anything you change in there, you can send settings and you can send it to both devices. You have to make sure that you send it to both devices. When you hit send settings, it doesn't show me because it's a demo, but it'll ask you, it says modified settings or all settings, and then it'll say this device, all devices. When you do the basic settings, you would send settings, send them to all devices. You don't need to then go into each inverter and do it. If you're using things like assistants, that won't send to all devices from the first one. So you have to go into each individual inverter and make sure that you've set all of those settings in each inverter. Like, I get pedantic about setting all of the right settings in the inverter. So even if I set it correctly in one inverter, I still go every inverter and check that the right settings are in there. So, which can be really frustrating when you're on a site and you've got 12 inverters, because it can take you quite a long time to load it up and shut down each inverter. Anyone know electrician? So, we're still good on here. We'll have a break in a sec anyway. So yeah, once you kind of finish setting the settings, always remember to send the settings. We find we get lots of people that go, I put all the settings in, and then they've done, and then they close the window, and they go, oh yeah, that's all cool, I'm done. And then they forgot to send the settings, and then the system doesn't work. Is quite common. Same thing again, once you step through it, you would step yourself into the next inverter, load that up, make sure all the settings are exactly the same. Any assistance that you need to install in that inverter, install them. And that's sort of the basics of doing a parallel system. The programming side of it is just always remember that you need the assistance on all the inverters, and you have to go into each one to do it. Is the key bit. Yeah, have we got any questions so far?
If you're doing any software updates,
Yep.
do you lose settings?
Yeah, every time. Yeah.
So what precautions?
So there's a couple of different ways that you can do firmware updates now. So if the system's got a GX device and online, you can actually do it remotely, or you can do it on site via the VRM portal, and you can drop all the existing settings straight back into it as well, which is much faster than doing it manually. We quite often, if you're doing a site and you have to do a firmware update for whatever reason, if it's an existing site, quite often you don't need to worry about doing a firmware update. I always have a really rule of thumb, once it's been in and working, unless there's like a reason, or there's or something's changed in the change log that warrants you to go and do that update, we generally don't do it. But if you are going to do it, I always load up vconfig first and save the file. Save the files of all the inverters or whatever it is, and then just upload, like do the updates, and then just upload the configuration back on that way. That tends to be the fastest. After we have a break, I'll go through the VRM portal and I can show you how we actually go and do updates remotely. Updating remotely is a bit of risk involved with it when you're doing it, but it can be a lot quicker. It can be a lot quicker programming a system through VRM portal too. But yeah, we'll run over that just after we have a break for coffee. Yeah. But yeah, anytime you update, you drop your settings, and it can be quite frustrating having to go back and re-enter it, especially if you forget what the settings were. Is there anything else?
I have a question. Is multi-plus designed to work on split-phase generators?
Is it designed to work on three-phase generators?
Split-phase.
Oh yeah, no, it can. Yeah. So if you come back into here, I don't know if you can see it from all the way back there, but we have dual phase 120, 180 and 240 for the degrees of separation. So we'll work on split phase. Yeah. Something we come across it a little bit in Australia. It's quite I don't know how common it is. Is it common here?
Yeah, it's only one group of customers, the Americans.
Yeah.
They bring their own stuff, you know.
Yeah.
Their own generators and things.
Yeah. So Victron have a range of American inverters as well. So if you are looking at them, like doing a boat or whatever it is, have a look at what they've got at their disposal, because that's a big growing market for Victron, the Americans. When you're programming or doing split phase, you can actually see it in this setting here. Yeah. Cool. We got any others? Oh, good.
Does the ambient temperature on the Victron affect its temperature system? The temperature is high.
Yep.
Normally on the charger, because what happens is they close the boat.
Yep.
And then when the temperature increases,
Yep.
it stops charging. So
Yep.
can we control that one? If the temperature is high, it shuts off, and then it comes on again. Because what happens when the flow comes in,
Yep.
it basically stays on unless somebody goes and then
Restarts it.
Yeah.
Is that on a DC or is that just a solar charger?
It's basically onshore power.
Mm-hmm.
Inverter.
Oh, inverter charger.
Yeah.
If it's plugged into shore, it should be passing through. It probably just needs, I would say it needs an update. There'd be an issue with maybe its temperature control. So if you're plugged into shore power and it's all closed up, it should just pass through and the inverter should stay on, and the inverter should probably be getting hot.
It's normally left on charge.
Oh, charge only? Yep.
Yeah. And then when the temperature increases, it splits off the charge.
Yeah. It probably never needs, like, so is there, and yeah. it probably just could be left in invert mode. As soon as if it hasn't got anything like ESS or the pass-through, you could probably just keep it on is what would be the way. But temperature does like all of it, doesn't like getting hot, and if it does shut down for over temp or overload, it won't reset itself. It always has to manually be changed. There is ways around it if it's like a nuisance. It just depends on how elaborate you want to get with the configuration of the system. You can set settings in there to reboot it in certain scenarios if you want, or if you had a GX device, you can program relay 2 to turn the inverter off and back on. You can do all sorts of stuff like that, but it really gets down to how elaborate that they want the setup. Quite often just turning it, But in that scenario, if they're parking their boat and plugging it in and they're just leaving it on charger only to charge their batteries, you can leave it on. It still charges. It does pass power through, but you could isolate it somewhere else. That might stop it from overheating, maybe. And or if it's happening a lot and not restarting itself once it's cooled down, you could just check the firmware as well, because sometimes there has been, like we found a fault with Victron in 3-phase system with temperature compensation, and we had a site that kept going on over temperature, but it had a grid connection on it as well. And what it should have done is it was getting hot, was pass more grid through the phase that was working extremely hard, but it just wouldn't do it, and then it would trip out and take the whole system out. Now it's kind of, once we found that issue, it's just Victron did a bunch of firmware updates. They never picked up on it during their testing, and they resolved it, I think, like in a couple of days. Pushed out new firmware and it was all fixed. So, yeah. Cool. Should we have a break for coffee, Toby? Yeah, it is a huge amount of information to try and take on with Victron. I know I've sat through a lot of Victron training sessions before, and a lot of the time when they do their tours and they come around, a lot of it's just very general, and it kind of goes it goes over a lot of their product sets and where they're used and all the different pieces. It doesn't really delve into programming an inverter and all of the bits and pieces. So hopefully running through some of that stuff and with a little bit of guidance, like maybe the next time you're in front of it and doing it yourself, that a few of the bits make a little bit more sense, and if they don't make a little bit more sense, you've kind of got a bit of a basic grasp of where it's all at, and calling the Solar Fiji guys to get that next level of support, just to help you get through and get it up online. The more you do, the more you're involved with it. The more the more it's going to sink in. You're going to understand it, and you're going to come across problems that might be unique to you. There might have been other people that had those problems, but once you work yourself through those problems, that's where you really do learn the ins and outs of how a product works. Just to give an example, because I've been building with Victron for over 10 years now, and we've done everything from the really, really tiny stuff to obviously the really large stuff, and we've blown stuff up. We've come across huge amounts of really complex problems, complex site problems, little niggly problems. It's like really hard to work out and explain, but it's the one thing that, and I know the Solar Fiji guys, and it's the same with us, that we stand by the product, and it is a great product. It's a bit of a learning curve. my we're going to jump into just, this is probably like, we do about anywhere from like 3 to 4 reasonable size off-grid installations per week in Australia, and that could be all over the country. And I spend a lot more time in the office these days than I get to do in the field. So probably my favourite part of Victron, and probably Victron's strongest point, and it's the strongest sell point for your customer, especially if you're doing resorts, especially if you're doing stuff on remote islands, and dealing with people, is monitoring and system monitoring. I can't emphasise it enough. Victron's monitoring equipment, in comparison to some of its competition, is extremely affordable, and it can save you huge amounts of money. It can save you heaps of headaches. It can save you heaps of time. With everything that happens with the system. So I'm going to run through. I've brought up a bit of an example here. This is a site that we did about a month ago. It's an outback station in the middle of South Australia. Really remote. So the closest town or city to this is 4 hours away. When you're doing projects, that's the nearest place, and that town might just be a service station, and that's it. So this is remote as you can probably get. Or probably if you would get any more remote than this, you would be in Antarctica, I reckon. But the beauty with Starlink, the beauty with internet now, it's most of these places have got Starlink. The internet connection is really good. So the benefit for us is we can watch that system perform. We can see what the weather is on site and see how it is relatively, what the system's doing, where the battery state of charge is, what our load is. And this site as well has DC coupled solar, and we have our Fronius that's AC coupled solar up there as well. Being able to look at that in a live sense, if a customer ever rings you, who goes, my system's doing this, and it's a lot to take on Victron when you're an installer and you've got the basic understandings. Like for a customer, it can be quite overwhelming. So for them to try and get their head around what the numbers mean, what it's doing in particular bits, can kind of be hard to explain. And if you don't have a visual on it, it can be really tricky to let the customer explain to you what the system's doing, what lights are flashing. Like it can get quite tricky quite quickly. And this is where the VRM portal comes in. So when we start looking at the VRM portal, this is the main display, which is the same display that you basically see on a color control or a GX device, and it would show all the devices in that system and what they're doing at any given point in time. As we scroll down, we can actually see what the performance of the system has been doing. So, and you can select that over whatever days, months, whatever it is that you're looking at. Victron have also recently introduced where they pull in data from a program called Soulcast, where they try and predict the future of the irradiance for the following day. But I'm not going to really go into that because it's not really applicable. But looking at system data, the thing that the VRM gives you is it makes it super simple to look at a system, monitor a system, and see what the performance and everything that it's doing. So this is our site for the last couple of days. I don't know what drop that for. Maybe my internet connection's not great. But basically you can see the red there being their load, the yellow being the solar producing, and you can obviously see when the solar is picking up in like these sections here, state of charge is climbing up, flattens off, the solar follows the load once that kind of gets to that point, and then it will discharge, and then rinse repeat. Does that day in, day out, this site. There's some really easy bits in here with the customer that you can actually look at particular sections of the system. Consumption is a really key one if you're trying to do an analysis on how much power they're using to how much generator and what source that's all coming from, the power. You can look over these little graphs down the bottom here. This site hasn't used any generator, hasn't used, there is no grid, so it won't use anything from there. But the day since we installed this system, only 2% of their power has actually come from generator. Would be a big success in my eyes. Diesel costing Wilpurina would be about $2.50 Australian a litre. So they were running 24/7 diesel previously. So it's a big saving for the customer, and them having access to see all those graphs and stuff is the feel good really for them to do it. The way that we go about setting up on the VRM portal with a GX device, I'm going to show you remotely with a GX device touchscreen about what the code is that you need to pull out of the GX device, and how you go about setting that up on Wi-Fi. So, or Ethernet. Ethernet is just plug and play. You plug an Ethernet cable, plug it into wherever the internet source is, and you're up and going. But Wi-Fi, there's some tabs that you can run through. So this is a GX device. This is the actual screen that you would see if they had a touchpad or a color control. And you can also dial into it remotely through the VRM portal. When we this site might not have been the best one because it's probably not the world's fastest internet, but yeah, when we bring up, it loads for me. So when you load up the menu, which is going quite slow for us, but you can see here that it lists all of the devices that we've currently got connected to this GX device. So we've got 3 Fronius inverters. We've got a Victron 450-100, a Victron 450-200. The site has a Pylon Tech battery. See if it scrolls down, and this site has 2 Quattro 15 inverters on it, in parallel, supplying 30 kVA. Is my internet going so slow? The downside when you got a slow internet connection is it can freeze up on you slightly and can take quite a while to jump between menus, which can get quite frustrating. once we've kind of gotten through the device list, any of those devices you can dial in, you can see particular settings within those devices, and it makes it really easy. If you've got a fault with any particular appliance, there'll be a notification. You'll be able to see it, and you can try and resurrect it or have a look and try and fix it from there. When you go into the next tab, which is settings, which is going to take a little bit for it to load based on what it's been doing. There's a huge amount of settings within the GX device. But the kind of first step that we would do to get that GX online is either to plug Ethernet cable in direct to the internet source, or you could set up via Wi-Fi. There is a Wi-Fi tab in the settings list. You literally click on it, it'll find the networks, you connect to it, and it's done. It's a really, straightforward, simple Wi-Fi connection. It's super self-explanatory. That's not what I wanted to do. What I might do, I'll go onto a site, which is our office, which I know has a faster internet connection. So you see, when you've got a faster interconnection, everything moves a little bit smoother for you. Not that you can't get through the other one before, but it probably wasn't a great one for me to choose for running you all through it. Once you've got your GX device set up, you can scroll down, you see the Ethernet setting there, and then there's a Wi-Fi setting. When you connect on Wi-Fi, we don't have an adapter plugged into this device, but basically it will show you all the Wi-Fi networks. You click on it, you connect, put your password in. It's quite straightforward. When you're going onto the VRM portal, there's one code that you need to be able to add the system online. You click on VRM portal and there's a portal ID number here. Everything is working extremely well. When the last contact 2 minutes ago, it keeps sequencing. Connection error, no error. It means that it's communicating and talking. It'll as soon as it's connected to the internet, it'll start feeding data. So you don't need to set up the portal straight away. If you come back and do it in the afternoon, or like when you get back to the office, it can be done that way. You just need to make sure before you left that it's saying last contact was relatively recently and there's no connection error. Once you've got that ID number, when you would come back into a system, you come back into this little section here of the VRM portal. You would hit add installation. Depending on the device that you've got, whether it's a Servo GX, the Ekrano, the color control, you would click on it relative, whichever one it was, put that ID number in, give your installation a name. I always get quite and like an installation name. Like we get quite a few people that add installations into our portal, so we can look at them and help them dial into them, make fix-ups and stuff. I always really love it when people put the location of the site first and the last name, but name it however your structure is. Once you've done that, you connect to it, and that's it. That's how simple it is to try and get the system online. That ID code, enter it in, and you're up and running. All that data will start feeding into the portal. So once you get all of that data into your portal, it'll start displaying like this. You'll have real-time data. You'll have weather data based on the site location. When you first bring up the portal, you can come into settings, which is on this tab at the side. You can give it the location. So to give you an example, that's where that site is located. That Roxby downtown is the closest town to it, and it's a very, very long way away. When you scroll out in the map, that's where it is in South Australia or in Australia, so completely in the middle of nowhere. I think like two families live out there. I think that's about it. And this site as well, this site would be getting up to, 55, 60 degrees, or close, 55 I would say in the middle of summer. The next step would be to add in your users. So if there's multiples of you that work that have accounts that want to look at it, you can set it up that way. At My Energy, we just have one generic account because it just makes life a hell of a lot easier. And when you're adding the customer in, you would just go invite user, you add their details in, giving them the access level and just calling them user. And then you can write them a message, follow the prompts, whatever it is, send. Customer goes through, gets an email, and they will just go through and follow their nose. I haven't had a customer, I've had one customer in all my time doing systems that couldn't figure out how to do it, but she was 89 years old, so she could barely use a computer. That's the basics of getting yourself set up on the VRM portal. So the other few bits that you can do, and the reason why the VRM portal kind of beats a lot of its competition is the amount of data that you can pull from the system. So every device that we've got attached to it, we can dial in and graph up and see all of the different bits accordingly over that time. So when you click up here in the top little bit, we have this thing called widgets. And so as you can see, we can see the gateway, which is the GX device. We can see the V bus system, which is the inverters. And there's 10 available graphs that we can pull from that. The battery, which is the pylon tech, we can pull 8 different graphs. Solar chargers, PV inverters, and then we can get fancy. If you've got really in-depth stuff, you can actually create your own widget, pulling particular bits of data as well. Some of them you don't ever need to know. You might select the ones that you need to look at all the time. Like we always look at DC voltage and current and load output are ones that we are commonly looking at for fault finding. But once you've basically got that all there, it brings it up in the graph down here. So you can actually see what state, whether the inverter was inverting, was on, charging, bulb, generator, whether there was any alarms. It was always really, really handy. So, and then you can bring it in, you can dial into that graph at a much, much, much closer view. You can pinpoint out sections, seeing what the voltage got to at particular times. You can also set value ranges to show just the peaks of minimum and max data, which is makes fault finding or seeing if the customer has a fault, and makes it extremely easy. A few things that when we're doing fault finding, and what I've always found really handy is what you'll find with Victron equipment, and it doesn't matter whether it's just Victron or it's any other brand, fault finding with equipment, especially on DC bus stuff, charge controllers pump out their own voltage. So if there is no cable attached to it and solar's working, it'll have a voltage. Your inverter may have a voltage. The way you would go through and fault find is you can see differences in voltage. If you're seeing different DC voltage at different parts of the system, there's generally something wrong, and you just got to figure out, you know, where that is. But having all of this data and being able to graph it, see where it is, see what the voltages are doing, seeing if things are charging and discharging the way that they should from measurements on that device, work really well. We have what they call the device list. You can see all of those same things. You can see the Froniuses, the MPPTs, everything listed in there. If you select on it, it'll show you the IP address. It'll show you what firmware version. It gives you a whole heap of information of what it's currently doing and all of those bits and pieces. We can also remotely firmware update. So any devices that are attached to it, the GX device, the smart solar chargers, the inverter chargers, we can dial in and change them all remotely or update them remotely. I'm not going to go into how you go about updating a multi-plus and quattro remotely. It's probably doesn't apply to a lot here. It's quite a tricky process to go through, and if anyone needs to learn how to do it or wants to learn how to do it, come up and see me when we break off this afternoon, and I can show you how you go through doing it. But it's better doing it one-on-one, so you understand the nuances of it, because there's some steps in there that if you stuff it up, it can be disastrous. We've had a customer that did that. They did their own remote firmware update. They've somehow had the wrong access level, and they dialed into this section, and they go, "Oh, there's some updates to be done." So, like, they clicked on the first one, did the update. The charge controllers don't lose their settings if you do an update on it, so that's really easy and straightforward. You can do that. You can do that remotely. It doesn't take a lot of time to do it. He did all of them, and then he got to the Quattro. And when you get to the Quattro or the Multi Plus, there is about 7 warnings as it steps you through. It goes, make sure this is right. Make sure this, your internet connection's solid. All of these steps, he managed to skip through all of them and update his firmware. It dropped all the settings on the Multi Plus. We had an AC coupled inverter on the system. He had pylon-type batteries. He damaged the BMS on 2 pylon-type batteries because he got rid of the PV inverter support. The solar just went to full power. The battery was full. It kept shutting down and faulting and then switching itself back on. It was not a good scenario. So if you're talking to customers, and especially if they've got the wrong access level, and some of them might have been rolled into with recent updates into the wrong access level, we always tell them don't touch the firmwares. It's not a mobile phone. Your updates we will update it if it's required. So that kind of gives you, but it's really great from your side. If you've got a niggly issue or something's happening, you can push a firmware update, see if it fixes it. It's a really good feature. The other one is remote V config. So to dial into a Quattro remotely, or a Multi Plus 2 remotely, we have the remote V config feature, which is really handy if you're making generator adjustments or setting adjustments. You can do it all from your office or a laptop, wherever you are. You know, I did one this morning. I had an issue with the job and dialed in, quickly made the setting adjustment, sent it, done, and we're back on track. You bring it up, it shows you what that inverter is. You hit download, it runs through the motions. Just queries the product. And I went back to the site that had a not great internet connection. But there we go. Reading setting data. Reads the grid info. It'll download that file. Or read assistance next, I think. Yeah.
Sharon, I have a question.
Yeah.
How many people can get into VRM at one time?
How many? You can have as many users on it as you want.
Okay, let's say we have a setup there.
Yep.
It's a test. Everybody here in the class gets to that site.
Yeah.
Can you do that?
Yeah, of course you can. Yeah. Yep.
It would be good if everybody has it on his cell phone and plays around with it, but just for experiment purpose.
Yeah. You can dial in, like if you've got a VRM account already, you can just set up and have a little play around.
Yeah.
You need sites. Like if you can set up a VRM account, but you need a site.
Bottom.
Yeah, site to play with. You could use a test case of the site here and do a few bits and pieces. Like once you've downloaded that setting, you can you see it there in your files. You bring it up, and there's the site file for Wilperina Station. So I could make any adjustment I wanted to those inverters. I could save it, and then I just re-upload it. All the setting changes are done, and happy days. Really, hopefully, all of those settings are all good. They're sort of the main features of dealing with like remote sites and monitoring. It's super key when you've got stuff that's far away from you, and I've lived it and been through it. Off-grid systems can go wrong, but the faults can occur, stuff happens. It just is the nature of what we do. But with monitoring, being able to see it, dialing into it, it saves you so much. It saves you a hell of a lot of money. For a not so expensive device, it can save you a huge amount of time and money. Anything that you've got on sites as well, you can create notes. Like a lot of our guys, if they've done stuff remotely, they might note that down as a bit of a change log on the site. You can add photos as well. If you're not worried about your personal data being shared to the rest of the world, you can actually put it up on the Victron World portal, and people can just dial in and see your remote site. They can't change anything or do anything, but they can see how much power that you're using and when you're using it. Is something that you can look at. You can also embed, the front page on your own website. So if you've got some projects that you're displaying on your website, and people want to have a look at stuff that you've done, you can actually show them. You can embed this whole screen here within your website. We do it to show off projects and bits and pieces, which is quite good. The other two main bits when you're looking at a system is looking at the alarm logs. These were done quite a few months ago, probably when we were commissioning the system. So we've got a low battery alarm and a high discharge current alarm, which was active for 7 seconds and 32 seconds, which both on the same day was probably the day that we did the installation, I would say. If you've got active alarms, it would show you an active alarm in this window. Quite handy to find out what the device is that's causing a problem, and all of those bits and pieces. The other bit that we have in here, which is only relatively recent, is an event log. So any user that's attached to it, it'll log whatever it is that you do to that system, or if you're dialed in, or anything that you do to it, it'll keep a track of it. So it's showing here today, I dialed into the remote console, it was accessed by My Energy, and then I did a firmware update on the 450-100. The thing that is really handy for is that same example I used with my customer that did the firmware update. He rang us up in a complete panic that his system had shut down and was going into all these alarms and faults. And I dialed into it remotely and looked at the event log, and I said, did you do a firmware update on the inverter? And he goes, no, I haven't touched it, I haven't done anything. And I'm like, I've got an event log that says Jake had, updated charge controller, GX device, firmware update on the inverter. I said, that's not what the event log tells me. And he goes, So it's really, but it's the same thing. Like if I took that phone call and he goes, this is what my system is doing, and I go, oh shit, that's not good. Like, what's happened? And he goes, no, I didn't do that update. This job was 4 hours away from our house, and we had to get someone out there that day or the following morning. And, that's expensive. Like, I could bill him at that point because it was him that made the mistake to do that. So it's, if I didn't have that, I would have got to site and probably figured it out anyway that he'd done that. But if he adamantly was like to me on the phone, I didn't do any updates. I'm like, yeah, the log's not telling me that. So I sent him a screenshot of the log, and then he admitted that he did it. So, but in that same thing, like you, it's just, again, it's another safeguard. It saves you money. It can make you money. Having that data. Data's the most valuable thing in off-grid power systems. And I stress it all the time. We literally don't do systems without data, or without monitoring and data. Quite often, even small systems now, we will put SIM cards with GX, GSMs, and maybe put 12 months of data on the SIM card. So, because that first 12 months is where you're going to have an issue. Or you're going to need to figure out what you might not have got an elaborate load assessment, or it just gives you so much information that you can utilise to try and sell them some more stuff. The last bit of the VRM portal, which is quite good, is their reporting tool. You can create reports, economic report for your customer. Customer might go, I've spent X amount of money and I'm not saving what you told me on diesel. Well, I had this recently, a big, large commercial site that we did. It was a $1 million project when we did it, and the customer came back to me 2.5 years going, I'm still burning a huge amount of diesel. And he wasn't in the first year, but year 2 rolls around, his season kicks in. I've used double the amount of fuel. So we did a report. We printed an economic report for him. We showed him how much money he'd saved with the system compared to just pure diesel. And then we also showed him in that report that his loaded increased from the previous year by 60%. And the system was only ever designed for this. It increased by 6%. That's why your fuel costs have doubled from the previous year. And here's your option. we can give you more battery, we can sell you more solar. And he goes, once he has the numbers, and most people, you can't argue with numbers. So he goes, all right, let's put more battery and solar in. You know, it's another big project to do. So it's those reports, and the Victron's report is really basic and simple. You like click on it, you tell it whether it's a generator, you give it yourself what a maintenance cost for solar would be, a generator maintenance cost, some fuel price, a generator size. Uses some generic numbers just to pump out a very basic report for you that you can show to the customer. You can also set it up as a reoccurring report that can get sent to them once a month. But you know, commercial customers sometimes might be interested in looking at it. Sometimes it's just for feel good sake, but it's nice to know that it's in there and that you can do it. And that's basically the premise of the VRM portal. Has anyone got the VRM portal set up and a few sites on it currently? Yeah. I probably, like, the more sites that you have, you can actually get a little bit more elaborate with your texts and emails and bits and pieces. I don't think it's probably not really worth me running through different ways that you can set up systems, but you know, you can tag each job. You know, what we tend to do is throw tags in there like pylon tech, or AC and DC coupled, or generator or hybrid tags. So if we're looking for particular type of systems to show, you can narrow your search options down quite quickly. Do you have any questions?
How do you search based on tag? Just on the top section?
Yeah, so if you just search installations and you've got tags, you can search via the tag. So when you're in an actual installation itself, let's see. So you come up in in all your installations here, and then you got the tag filter.
So for example, the RS units are being pulled, you can tag.
Yeah, so if you've gone through and tagged them all as RS units that you installed, you can just click on it, find it, off it goes. We've slowly gone through and started tagging stuff just so, you know, my office admin, go and find the pieces that are in each of the systems, tag them accordingly. So then if we ever do have issues, we've got recalls, we've got any bits, you can just quickly filter out what it is that you need. You can also look at you can also look up sites on a world map of where systems are in your portal. You can download spreadsheet data. So if you get some of it's not really necessary, or probably doesn't even really relate unless you've got a really big problem. But it's just the amount of information that Victron carries. It's super helpful. The other bit as well that you've got is you can bring up all your active alarms in systems. So if you have a look at our list at the moment of jobs that have active alarms that are going on, I've got a Madeira Plain station which has got a tank level alarm. We monitor. That's a really remote site, that place, and we have a fuel tank sensor that's telling me that the fuel tank's nearly empty. So that customer would have that on his portal. He would see his fuel tank's empty, get in the ute and go and drive out 200 kilometres to where his site is to fill it up with diesel and hoik it back. Error code on a solar charger. One of my guys has probably already looked at that, but we can dial in, have a look. As an example, it's saying internal error on a charge controller. use it as an example of what to go and look for. This site is doing this as an example. This is for a winery in the Adelaide Hills. It's running just a pump, bit of AC DC coupled solar. It's mostly daytime pumping that they do here. But one of those errors, error 200 in fault. So you can dial in here. You can see that there's DC voltage sitting there. It's not producing at all. My first school of thought would be I'll probably double check whether it needs a firmware update as an example. And it seems that it's obviously seeing battery voltage there as well. So it's got everything there. It might be a crook charge controller. Around this time that this system was installed was a time when Victron did have an issue with this particular model of charge controller. But if I went device list, firmware update, see if it loads up. It's taking its time. Well, I thought that was going to be the case. It decided to time itself out. Looks like it'll time itself out again. But yeah, normally what would happen, that would drop down with all your devices that this site would probably could do with the firmware update. You would go through, update each of the charge controllers, hopefully that it clears the fault. The fact that it's got an internal error on it, generally in Victron world, if it comes up with error 200, it'll probably say that it needs to be replaced. It was saying there's a setting in here which,
So when you get notified of the fault, you get emailed directly? Or you
yeah, if you've got email notifications on. If you've got the Victron app on your phone, you can get notifications too. We've got too many sites now. It used to drive me wild, the notifications. So I ended up turning them off. But you can get notifications on your phone, your watch, your iPad, your computer, and email as well, which is handy. It's handy for for a customer that's got one site, because then they can get notified and they can see it all the time. So I'll just double check that we've got a particular But yeah, you can also sort, like, so the more jobs that you have in your list, you know, you can sort it based on the date that it was added. You can also set it to, if anything's in alarm, it just pops straight to your installation list as well. And it's always quite a handy thing as well, like, you know, things do, you know, break or they go into error or there's a customer fault. Customers love it if you see an error and give them a buzz and say, hey, I saw that, you know, one of our guys will call and say, hey, we've got such and such internal error. Shows them that you're on it, and they're, you know, can fill them with a lot of confidence, especially when you're looking at starting to do bigger projects and bits and pieces. If you get that feedback and those type of reviews, it can help you a lot. Yeah, I don't know why that won't let me on there. Yeah, so that's basically the VRM portal. Does anyone have any questions about it at all? Do we take another break? It's pretty much 12 o'clock.
Yeah,
It's a bit of a section, then we can just do a Q&A
Yeah.
after lunch and run through questions that anyone has.
Yeah.
I'll show you just quickly. Victron are about to change the GX device. The latest update 3.5, which is on its way, it's not very far away. The actual look of the GX device is changing. So they're, with all the boxes where things are flowing and all of that, they're changing it. This is the new version of it. I'll give you a little bit of a sneak peek to it. Some of you may have already seen it. Some people have already managed to get it and get it on the GX device before it's released. But so that's what it'll end up looking like, the GX device. We'll show you your load, where your battery's at, what your grid power is, what your solar's doing. Give you a little rough, just a little bit of a display. Like that, you can bring it back into the overview, which gives you a very, very similar looking than the other one. It's just a little bit more modern. It'll give you some graphs and bars and just bringing it to the 2024s, I suppose. Notifications, all the settings, basically everything is still very, very similar. And yeah, that's basically it. That's the new thing that they've been working on. There's a heap more integration that's happening with Victron and the GX device. You can pull data in from ComApp controllers, DSE controllers, Fisher Panda. They're making it more accessible for third-party manufacturers to be pulling data into the GX device, which again gives you a ton of flexibility, gives you cross-compatibility with product sets, and yeah, works. Yeah, you know, once it's released, should make it quite a big difference. But yeah, I think we'll just break for lunch now, and then if you've got and can think of any questions, we can just do a Q&A on Victron and some of the stuff that we've covered, whether anyone has any faults or system issues that they're dealing with currently, generator issues, whatever. Throw them at me. I'll try my best to answer them. Yeah, cool. This last little bit for today, I think like if we've got any questions or anything you want me to sort of dart back over again, I'm more than happy to do so. I've spoken to a few outside. I just wanted to run through just a couple of other bits when you're just configuring a system. I'm going to keep it pretty simple to single phase systems, but just another couple of little tips and tricks basically that you can do when you're setting up a system. If you're doing a lot of generic systems with all the same settings, same configuration, you can save the config file and upload it to just about everything that you're doing. It can make life extremely easy. You have a good labeling system. You can pre-save a lot of the bulk settings. So if you have a setting that or a system that you know you're using over and over again, I always recommend saving it. You can also print and export the settings as well and get a complete overview of what's been set. We quite often do this in larger systems, or commercial systems, where we might be putting the list of settings that we've set into the job pack or the file that we're handing the customer at the end of the day. When you go and save the settings, you know, another really easy feature that you can use is if you're setting up a three-phase or parallel system in VBus Configurator, you can actually save the settings on the first inverter. When you load up the second one, you just load the settings you just saved and rinse and repeat for however many inverters that you've got in the system, and it's another quick and easy way to actually get through it. There is ways as well, and vconfig is exactly the same. You can set up, if there's particular batteries that you're using all the time as well, if you hit battery type, you can see here there's a list of batteries up until where it says flooded tubular plate. They're all of Victron defaults. I've got a couple of others in there for Red Flow's BYD Pylon Tech batteries that I have used a little bit in the past. What that means is it's quite easy then if you're putting charge parameter settings in. You can just create a new type, hit OK. It pops up with all our settings that we use for Pylon Tech. You hit OK, and it's in there. So no matter what battery or brand it is that you actually like using all the time and working, if you just take that little bit of effort, save that battery configuration setup, it can save you a huge amount of time in the future and having to pull manuals out if it's if there's big gaps in what you do. Just to run through real quickly again, just the basic config setups and where a lot of systems go wrong. Piecing systems together and wiring it up. It's easy to follow a schematic, all the bits and pieces. There's not really too many guides that tell you specifically how to program and configure the system once it is set up. The key bits that you need to be looking for, and where we see the most amount of problems, one was those charger settings, but if you get in the habit of setting up and saving those batteries that you're using all the time, that can be quite easy. The second one is just generator connections, and the generator connecting into a off-grid system can be difficult. Depends on the generator, and there could be multiple different reasons as to why the generator won't connect. The main settings to look for in that scenario is what you've set the input current limit to. That input current limit, if it's left at the default of 50, which is really common that we see, If you put a 5 kVA generator on it, it'll trip every day of the week and shut down. The system will try and pull up to 50 amps if it requires it. So you would set that. Another really rough rule of thumb that, like when we're setting input current limits on the generator, all generators come with a kVA rating. So generally, if you're getting the kilowatt rating, you'd be timesing that by 0.8. I tend to times it by 0.7, work out the current, and then that gives you a really sweet spot. It gives you a little bit of headroom on your generator, so you're just not pushing it to its max 24/7. It generally sits in a really nice place. It also kind of puts it in a spot where it can make it nice and easy for it to synchronise and connect without being hit with too much power. Once you kind of set that input current limit, there are a couple of other settings in here. So we've got the transfer switch, which has the AC load disconnect and reconnect settings. If you're doing multi-phase, or doing 3-phase systems, parallel systems, the AC load disconnect sometimes can be too low if you've got inverters in parallel. 180 volts for the voltage to get down there. If you have a 10 kilowatt inverter that's pulling 10 kilowatts through it, and the voltage that it's matching up to becomes 180 volts instead of 230 or 240, so a significant jump in current that you're actually pulling through componentry in the system, and it can cause damage. It's not as big a problem in the single phase systems, not as big a problem in a standard 3-phase system, but when you parallel up inverters, very quickly can become a lot of current that you're sucking through that inverter, and it's just a blow back feed relay could cause some issues. It's sometimes worth adjusting that. We would say setting it to 200 as the low cutoff is usually perfectly acceptable. You don't want appliances running, especially if you're 230, 240 volt grid. You don't really want your appliances running down at 180 volts and still being on. The other setting that we have here is UPS. So, the UPS setting is like a fast input voltage detection, and so basically it lines itself up with the AC input wave, and if it doesn't line up very well, it just won't connect and is rejected. So when you've got a grid connection, most of the time leaving UPS on is completely fine. It'll work a treat. If you're using a generator, a lot of generators, even really high-end generators, cannot have really great sine waves, or they can get warped very easily, especially when we've got quick load changes, all those type of bits. Having a battery system on it and connecting to it, starting to charge from it, they're all things that put big strain on a generator, and they cause the sine wave to wobble. So what ends up happening is the system might connect for a second and then it'll drop straight away because it won't like the fact that the sine wave is wobbling on it. If you're having generator connection issues, disable it. The transfer time is like nothing really still compared to with UPS on. You won't, having it off and the transfer time, you won't drop computers, TVs won't turn off. The only thing you might ever see is a slight flicker in the lights if they've got LEDs. But outside of that, it's the main setting. If you're having trouble connecting a generator to your system, disable it. In the inverter space that we've got, you've got all your load cutoffs. Again, talking to your battery manufacturer, reading their spec sheet, finding out what the minimum discharge they want that, or minimum voltage they want that battery at. It's quite important with lithium batteries. If you pull a lithium battery below its cutoff point, generally what happens is its BMS will lock it out, or the BMS inside internally will shut down, causing the battery just not to work at all. And then the only way to recover it is actually to pull the battery apart, put a charger on the actual cells and get them back up and over. And a nightmare of a kind of exercise that's not a fun one to be doing on site. As I said, with Victron and all their approved lithium batteries, a lot of them have guides. So you'll be able to see on those guides all the settings that you need to set for each of those inverters. They've usually been green ticked by Victron, green ticked by the battery manufacturer. They occasionally change it, they occasionally update it based on a few things, but that finding out those load cutoffs, state of charge shutdowns is quite important. Victron have another part of their system which is called Power Assist, which is this little box up in the top there, and it's an interesting little feature that Victron do and have been able to do. And the way that Power Assist works is that Victron, if you had a 5 kVA, if you had let's just call it in kilowatts. If you said you had a 5 kilowatt Victron inverter and you have a 5 kilowatt generator, Victron inverters have the ability to take the 5 kilowatts from the battery and the 5 kilowatts from that generator and pass all of it through to feed a load. So you can feasibly feed 10 kilowatts on the output side if you've got a generator running. The Power Assist boost factor is just a calculation that Victron makes on how much power, as it increases, how much power based on the input current limit that it can throw out ahead. In really, really large sites, reducing this number can really smooth out your performance of a system. In most single phase systems, leaving it at 2 is fine. Victron's golden rule is leave it at 2. Our experience has proven otherwise. We quite often change it and make it a little bit smaller, but we also don't really design systems that need to shoot up well over what the actual inverter is capable of. Power Assist is a really, really useful feature if you've got guys that are like welding and doing other bits and pieces like that. There's a huge white paper on Power Assist, how it operates in different scenarios. Definitely worth having a read to try and get your head around it. I've got a basic understanding of Power Assist and what they do and how they make it work. I've tried Victron a lot in more depth information about it, but it is a handy little feature in most scenarios. And finally, with just the basic setup, is the last one that we have is the charger tab. Like I mentioned before, if you can enter in details of the batteries that you're using, and then you can save those details, label it, it allows you to just be able to call on it each time. Saves you time. Anything you can save yourself a few minutes on site and make your life easier is well worth doing. Quite often, if I'm going over to do a commissioning project for a job or something like that, and I've never worked with that battery before, as I'm like sitting there on the computer doing a bit of research about it, I might set that battery up so I've got it saved and all the details saved in my actual computer to call on when required. The virtual switch in basic systems is mostly just being used to control the AC input, whether you want to ignore it, whether you want to generate a control. It's a feature that I don't actually use it a lot. I know our RV and boat guys kind of use it a little bit, but we tend to fall back onto the assistants because we have a little bit more control over what we can actually switch. And finally, we ran through it this morning, but assistants, you want an AC couple solar, you want a hybrid system, or you want to use and control hot water services or freezers or whatever it is. The assistance tab is where you do that. And yeah, kind of from there, you know, your possibilities are quite endless with what you can program, set up and achieve with just those basic assistants. And if anyone, you know, Victron have kind of moved a little bit from assistants. They're now in Node Red, which I kind of delved into a little bit the other day, but if anyone has any projects that require more complex control, they're more than happy to send me an email and we can talk about what it is that you're actually trying to achieve with a system. And it can be for any type of Victron system. Or you've got, you know, integration into you're doing a resort system or anything like that. If any of them have building management systems and you want to integrate data between the system and that, you're more than happy to send us an email and we can discuss how we can go about it. Again, vconfig is purely for doing quattros and multi-pluses and setting all the settings. vBus configurator is for setting three-phase systems, and vconfig just follows that scenario. The last one back again, which we went over a little bit yesterday, was Victron Connect. Victron Connect is where everything's kind of moving to. I'm not sure how much like longer vconfig and the others are going to stay in play, because Victron is trying to roll this whole programming suite into Victron Connect. It's just not here yet, and I've been hearing about that for 4 years, so it might be another 4 years before it actually happens. But you can do 90% of what you can do in the others with Victron Connect. It's far simpler, far easier to work your way around. Victron Connect has a couple of things. When you connect into an inverter or a Quattro or Phoenix inverter, it'll ask you for a password. That password's 3 Zs. If you connect into any of the other devices, such as like an Orion, shunt, a solar charger, the password will be 6 zeros. The only time that ever changes is if the customer has decided to set their own password, which can be frustrating when you're trying to look for it, but there is ways to reset it. There's a PUP code on the serial number. When you're on site, you can reset that password back to the default. Trying to think. Yeah, as far as the systems go that you're doing there, hopefully I've kind of covered off just some of the basics that you need for configuring systems. One of the things that I'd always say is the more that you're doing it, the more that you're taking in whilst it's happening. You know, if if you know you're working with someone all the time and they're the one programming, make sure you're watching over their shoulder and dealing with it together, soaking it all in, so it actually makes some sense. You know, learning in the field is and doing it hands-on is really valuable. Having a little bit of pressure on you once you're learning is quite valuable as well, because I think it helps it all make sense and sink in. It's the confusing bit with Victron that there's quite a few ways that you can go about setting the systems up, configuring them. There's lots of variations because there's lots of different types of batteries. There's lots of different types of system configs and setups. When we go from marine to automotive, when we go to houses to commercial, there's lots of nuances with each way and each system that comes across your desk. I'm a really, we have a really big trend in Australia where there's a lot of people that build what I like to call power boxes, where everything's pre-built in a lovely looking cabinet, and when they sell it to a customer, it's the one size fits all scenario for that customer, and there might be a few different sizes, and they try and pair it up accordingly. Every customer that I've ever dealt with building off-grid power systems, there are similarities between people, but everyone is always slightly different, and jobs are always slightly different. I know that Tony and the guys, and as a Victron distributor, we're all here to help. We all want you a part of that community, using the products, building on it, putting them in cool places, you know, getting all the feedback from them. You know, all of that stuff is really important to us, and we're here to help you guys, you know, become better installers, better with the product, and here to help you get on your feet with it too. You know, solar's you know, it's quite tricky. My techs back home, same thing. They live and breathe it every day, and you know, they come across, you know, problems all the time that you have to work your way through. It's just how our industry goes. But the more that you can, you know, fiddle around, tinker, play, get immersed in it, the more that you're gonna, the more that, you know, the better you're gonna become at putting this stuff together. I've kind of like this last little bit, like, you know, I really, if anyone's got any questions about power systems, you know, it can be related to whatever, generators, Victron, power system design in general. If you've got any questions, want to share it, you know, put your hand up, ask the question. I'm pretty sure I've gone over most of the stuff from Victron that would be relevant. If you've got anything you want me to delve a little bit deeper in now, or go over, I'm happy to do that as well with everyone. But yeah, have we got any questions or
programming bit of series relays.
Oh, what was that? Sorry.
The programming of series relays.
Yep.
Can you explain?
That's probably my weakest point in Victron. in that one, it's probably not my background. But what I can do is that product in particular, I've got a guy that I do work with over in Victoria in Australia. If you've got some questions on him, I can get you what he does them all the time. He's in the marine industry. That one product for dual battery stuff is just something that, like, I've never really been hands-on with to kind of.
Of course, we're getting a few loads that are being installed.
Yep.
And sometimes we have issues.
Yep.
Maybe the BMS, for some reason if we have to change it over here,
Yep.
it has to be programmed, so it would be really helpful.
Yeah, cool. Yeah, I'll take a note. I'll what I can do. Yeah, as a guy that I know in Melbourne does all the marine stuff down there, and yeah, he'll 100% be able to help you out.
And what sort have you actually ever installed a fire extinguisher for lithium-ion batteries?
Yeah, we have.
What do you recommend?
I could show you a photo. I was showing the Nasinu Fiji guys when I got here last week, and it's so we had a site in on the Nullarbor in Australia, which is like a really remote area, and that site had a once in 150 year flood. And like if you went there, it is as flat as the eye can see. You wouldn't even be able to tell how it could flood. We had battery cabinets out there that filled halfway up, and they were full of Pylon-Tech batteries, and they were useless to us at the end of the job. And so one of my techs, he loves shooting and hunting, and they're in the middle of nowhere. So he took one of the Pylon-Tech batteries out of the cabinet that was flooded and had been quite damaged. He plonked it out in the middle of the out in the paddock, and then decided to shoot it. And he shot it like 3 times, and it smoked, but it didn't catch on fire. I've been to like multiple battery factories in China and watched them actually like take the cells in the chamber, stab them, pierce them, all of those bits. And like the cells, like the way that they design them, especially lithium phosphate, like the chances of it catching fire, the chance of it smoking are really high, but the actual fire side of it is actually really low. In Australia, I've seen a few battery fires. I've seen battery fires with lithium batteries, but that wasn't the battery that actually caught on fire. It was the control gear. And terminations within the actual BMS and bits and pieces that caused it to smoke, which is pretty bad. But sort of the other things that I've seen for fire as well, is installation stuff, overcharging batteries. I've seen a lot of sheds burn down. Not that I've done, the sheds that we've seen DIY guys do and that in Australia, where they've bad cable sizes, connections, overcharging, batteries explode, catch things on fire. The really big thing where you get the push, and I imagine you guys would get it on expensive boats, is insurance. And insurance just asks for it. It tends to be why we work with like quite a few managed battery systems, and so we use a third-party fire protection relay. So when we have to have it because of insurance, I've got a big project at the moment where we're doing a megawatt battery, and it's all managed lithium battery, but to get their insurance through, and this is in an isolated, sealed room. There's no risk of it getting out and damaging anything else, but we've got fire protection relay in there, so smoke detectors are in the room. If anything smokes, it instantly shuts down every battery and isolates it, because every battery is managed. It shuts the inverter system down, shuts the whole site goes down in case of that scenario. And then second to that, there's another trigger on it that it can trigger the, what do you call them? We can buy them in Australia. They're like a firebomb scenario that there's like 4 of them across the top of the battery banks that just douse it.
You would actually recommend in Fiji, if you're installing lithium-ion,
Yep.
you have to fire safety.
No, I like, unless the insurance comes, like in big jobs, in big sites like that one that we're doing, yeah. I've just never seen it happen, and I think like a lot of the lithium batteries now and lithium manufacturers, as long as you're using reputable brands and they're designed for purpose, I don't think you have to worry too much. Yeah, if you were using things like, you know, I've seen some not very good put together batteries out of China, and just things that you know as an installer are questionable. Like you can feel it, you can see it, all of those things. Yeah, I would be saying it doesn't, like, you know, most scenarios I wouldn't be doing it. Just depends on, that chemistry. The big main one as well is now everything's moving to lithium phosphate. You know, in the really early days of lithium battery, you might have heard in Australia, I'm sure not too many of them would have been installed here, but the LG Chem battery was a lithium high voltage battery. They did a complete recall in Australia because it was a fire hazard. That battery chemistry was like lithium NMC, nickel, manganese, cobalt, and that they used it, and Tesla used it as well. It was so they could make the battery so skinny that it would sit on the wall nice and fit that residential market. The problem was with it is it's super volatile, and if it did get punctured, if it did have this happen to it, you know, or someone hit it with their car, it did have a really big risk of going up. And once it's up, you know, the lithium fire's going to burn basically. But yeah, in most scenarios, we don't do it in, you know, it's very rare that we install that sort of fire protection extra relay. But we're confident in the products that we're selling and installing. Yeah.
Alright. So any questions?
The grill face welding,
Yeah.
using a diamond wood.
Yeah.
So for the program, you
What was that?
for the grill face,
Yeah.
and using diamond wood.
Yes.
So how you can connect any cables,
You can go through and do in the setup, like you just load those 3 inverters, drop them in. You can run through the whole program of the system to make sure it's configured to do what it needs to do. You just load that demo mode into the thing, and then you can set up accordingly. It works really well. Oh, so yeah, that's a question I got asked yesterday, so I may as well run it again. And it's probably a question that gets asked quite a bit with Victron systems. Can I have a 3-phase system and have a single-phase generator? It can work. It's a trickier way of making a system work, and there's some ways that you have to set up a system. There's ways that you have to set up the system and configure the system and have the right components in it to actually make it work. So the simplest way to make it work, the system has to be completely off-grid for it to happen. The system has to be completely off-grid. It can't have any AC coupled solar on it. It has to be purely DC coupled solar. And you can't have ESS assistant on it at all. When you are setting up an inverter, let's put it into demo mode. Let's put it back in a 3-phase. So when we set up this 3-phase system that's here, you can see that green circle that's around those inverters. and there's that little box at the top which is switches group. What that means is if you're switching AC input into the system, all 3 inverters need to see that AC input to be able to shift itself into charger mode. It's to do with efficiencies, it's to do with controlling AC coupled solar. There's a few bits that are required because of it. If you are putting a single phase generator on, you need to set it up accordingly in VE config with that, but you need to turn switches group off. Once you've turned it off, send the configuration. That means that you could have every inverter doing something slightly different. One could be charging, one could be supplying low, one could be idle, doing not much, and they can be all doing different things at different times. Or you could basically feed it like that. When it's set like this, you can't have 2 single phase generators, one on each or one on a different phase. It's just one inverter on that line, one that you can put. We have some more complex systems in Australia. There's some more complex systems that we do in Australia where we have to manage, like our customers come to us all the time and go, oh, I've got a split phase supply, which is quite common in rural areas. They come and say, we've got a split phase supply, but I need 3 phase to expand my piggery or my dairy or my whatever it is. And they want to integrate that split phase supply into the system, which is much trickier to do. So the way we overcome that scenario, because most of those sites, they're quite big, we have AC coupled solar involved in it, we have a big mixture. What we would end up doing is on a site like that, we would program it to be 3 phase, switches group would be on, but that split phase supply, we'd work out how much power that can deliver, and we would put chargers onto those 2 lines, like battery chargers on those 2 lines, and switch them on and off accordingly to feed the battery if we required to bring them in to give us a little bit more oomph. It's a little bit more of an expensive way to do it, but it can utilise the grid power that they've got there, and it generally is cheaper than them, trying to sort out a generator and other bits like that. It's a far more complex kind of scenario to do it. That's really that 3 phase. If everything's DC coupled, you can keep it simple. Turn switches group off in the happy days. If you wanted me to go in more detail on how we do that the other way with the extra inverters, I'm happy to send you some schematics and show you kind of how we go about doing it. So it's a common kind of problem that we find in Australia all the time. Yeah. No, it's cool. That's a good one.
And then the question for the UPS.
Yep.
If you connect it to the grid,
Yep.
that's the voltage, no music charger.
Yep.
Yep. So how are you going to program it? Just complete the inverter?
So if it's just grid and in battery and inverter, so pure UPS. A pure UPS, you just have the grid connected to it, set your input current limit so it doesn't suck through too much power or whatever your circuit breaker you have on that input. You have your load on the output. That's it. Nothing, you don't do anything, hardly any programming. The only bit I would say in that, depending on what the battery is that you're using, you can sometimes go and find from the manufacturer, if you've got a battery that's sitting in charge and float for like a really long period of time, Victron do have in their settings here, where are we, in the charger, we have a storage mode. So this kind of gives you a little bit of an example of what that storage mode does. It's just a default. If the battery's been left in float for a significant period of time, it'll work itself out that it doesn't probably want to sit at that float voltage for too long. It drops itself down by roughly a volt, and then goes through its repeated absorption. You can check whether your manufacturer actually approves it and likes that scenario. If batteries are being kept in float 24/7, waiting for the day that the grid goes out, it can not like it because it's not cycling it and making it do what it wants to do. This kind of pushes it just a little bit, just to make sure that you're getting the life out of the battery. Yeah.
You can just get this 60 volts and just leave it.
Yeah. Cool. Have we got any other questions?
ESS and PV inverter system.
Yeah.
So the frequencies are basically
Yeah. So that question was for ESS. When ESS has PV inverter support built into it, so in all scenarios, when you're in ESS, there's a couple of different ways that you can control the solar inverter, the AC coupled solar inverter. You might have a site where you don't want to export any power to the grid. There's a walkthrough on how you set Fronius inverters up to make that work. We just recently did it at Maui Bay, where you change a couple of settings within the Fronius itself, and over Modbus, the Victron can control it to zero export. I won't go into it in full detail, it's a bit of a process, but it's a way that you can control it. You still set it up to be able to be frequency shifted, but when you've got the grid connected and passing through in an ESS system, the system just follows whatever frequency the grid is at, so it doesn't frequency shift. If the solar wants to produce full power, it'll pull full power and pass back through that inverter, which is fine. But when it isolates itself or EFL fails, it'll go back into that frequency control mode. Victron will ramp its frequency up to try and stop the production of that Fronius inverter. Yeah. Cool. So yeah, well, if we've got no more questions, I just thanks for coming here today and or the last couple of days and listening to me waffle on about Victron Power Systems. Hopefully you've I've covered a few of the some ins and outs and some bits about how you commission and program some of the products that are available. I can't stress enough, it's really important to be teamed up with the right distributor when you're dealing with Victron, because the way their network is, the way their support is through the distributor. Hopefully you've learned a bit. If you've got any questions at all, you can feel free to hit us up via email, or if you get in touch with Tony, I'm happy to talk about anything, any projects, whatever you've got going on. Happy to discuss. It's been a good experience for me. I'm not a trainer, so I spent all my time in the, I went through all of these steps and learned from experience doing it. I'm an electrician by trade, and you know, it's been a big learning curve. Put the effort in, you'll get there.
And a high school dropout, would you believe? And this is where he gets to.
Yeah. But yeah, you know, I've always been passionate about renewables. I think, you know, it's the future. You're in an industry that, like, there's only one way it's going, and it's up. And there's bucket loads of work for everyone. So it's you know, we all work together. I think, you know, we'll all become very successful. And you know, hopefully, you know, we'll talk and stay in touch. Be one big happy family. Plenty of work out there for everyone. And yeah, good luck.
Round of applause. So, Ciaram did very